Somewhere, something incredible is waiting to be known. Carl Sagan. The vastness of the universe, a journey into the cosmos. In the grand theater of existence, the universe unveils itself as an intricately woven tapestry of staggering scale and unfathomable complexity. To observe the cosmos is to peer into an infinite expanse, where galaxies swirl like distant islands in an ocean of darkness, where time stretches into incomprehensible epochs, and where the boundaries of space and thought blur. We stand on the shores of this cosmic ocean, gazing outward into the endless night, searching for meaning, connection, and understanding. This journey into the universe is not simply an exploration of the material world but a voyage into the heart of existence itself. The universe challenges us to ask fundamental questions: who are we? Where do we come from? What is our place in this vast, unfolding narrative that stretches across billions of years and billions of light years? To explore the universe is to embark on a quest to answer these questions, a quest that unites us in our shared curiosity and wonder. The birth of the universe, the Big Bang and beyond. To begin to understand the universe, we must start at its beginning. The story of the cosmos begins some 13.8 billion years ago with an event that defies common sense, the Big Bang. This is not simply a bang in the conventional sense. It is not an explosion of matter into empty space. Rather, it was the rapid expansion of space itself, from an infinitely dense and hot state, a moment when time and space themselves were born. Imagine, if you will, a singularity, a point where the known laws of physics break down, where the densities and temperatures are so extreme that they verge on the limits of what we can comprehend. From this point, the universe suddenly expanded, creating not just the matter and energy that would later form stars, galaxies, and planets, but space and time itself. The first seconds of the universe's existence were a time of extraordinary violence and change. The temperatures were so high that particles were constantly being created and destroyed. In those initial moments, the fundamental forces that govern the universe, gravity, electromagnetism, the strong nuclear force, and the weak nuclear force, were unified. As the universe expanded and cooled, these forces separated, each governing different aspects of the universe's behavior. In the first few minutes after the Big Bang, the universe had cooled enough for protons and neutrons to combine, forming the first atomic nuclei. Hydrogen, the simplest and most abundant element in the universe, was the first to emerge, along with helium and traces of lithium. These elements would later form the stars and galaxies, but at this early stage, the universe was still a featureless plasma of particles, a hot, dense, and opaque sea of energy. For hundreds of thousands of years, this hot plasma prevented the formation of neutral atoms. It wasn't until the universe had cooled sufficiently that electrons could combine with nuclei, forming the first atoms. This process, known as recombination, occurred around 380,000 years after the Big Bang, and it marked a crucial turning point. The universe became transparent to radiation, allowing light to travel freely for the first time. This relic radiation, known as the cosmic microwave background, CMB, still permeates the universe today, providing a window into the universe's early history. The CMB is a kind of afterglow of the Big Bang, a faint, uniform glow that fills the entire sky. It is the oldest light we can observe, a snapshot of the universe when it was only 380,000 years old, a mere infant compared to its current age. By studying the CMB, we have gained extraordinary insights into the early universe, its composition, its rate of expansion, and the tiny fluctuations in density that would eventually lead to the formation of galaxies. Cosmic inflation, the universe's unfathomable growth. One of the most astonishing ideas in cosmology is the theory of inflation. According to this theory, in the first fraction of a second after the Big Bang, much less than a second, in fact, something on the order of 10⁻32 10⁻32 10⁻32 seconds, the universe underwent a period of exponential expansion, growing faster than the speed of light. This may sound counterintuitive, as nothing can travel faster than light within space, but space itself is not bound by this limit. During inflation, regions of the universe that were once microscopically small were stretched to macroscopic scales in a fraction of a second. Inflation explains many of the puzzles that previously baffled cosmologists, such as why the universe appears to be so homogeneous and isotropic, the same in all directions, on large scales. Without inflation, different regions of the universe should not have had time to come into contact and equalize their temperatures, yet we observe that the temperature of the CMB is nearly uniform across the sky. Inflation solves this problem by stretching small, causally connected regions to vast sizes, making the universe appear uniform on large scales. But inflation also leaves its mark in the form of tiny quantum fluctuations, minute variations in the density of matter that were stretched during inflation and would later grow into galaxies, stars, and planets. These fluctuations are imprinted in the cosmic microwave background, and their presence has been confirmed by a series of increasingly precise observations. Thus, inflation not only explains the large-scale structure of the universe but also provides the seeds for the formation of all the structure we see today. Galaxies, islands in the cosmic ocean. As the universe continued to expand and cool, gravity began to take center stage. The force of gravity caused the tiny fluctuations in density left over from inflation to grow, pulling matter into clumps that would eventually form galaxies. Over billions of years, these galaxies would become the primary structures in the universe, each containing billions or even trillions of stars, along with vast quantities of gas, dust, and dark matter. Our own galaxy, the Milky Way, is but one of an estimated 2 trillion galaxies in the observable universe. It is a barred spiral galaxy, roughly 100,000 light-years across, with a central bulge of stars surrounded by a flattened disk of gas, dust, and spiral arms. Within these spiral arms lie vast regions of star formation, where new stars are born from collapsing clouds of gas and dust. The Milky Way is part of a larger cosmic structure known as the Local Group, a collection of over 50 galaxies, including the Andromeda Galaxy, our nearest spiral neighbor. Beyond the Local Group, galaxies are grouped into clusters and superclusters, vast assemblies of galaxies bound together by gravity. These structures, in turn, are connected by filaments of dark matter, forming a cosmic web that stretches across the universe. Galaxies are not static entities. Over time, they interact with one another, colliding and merging in a cosmic dance that can last billions of years. These interactions can trigger bursts of star formation, reshape the structure of galaxies, and even lead to the formation of supermassive black holes at their centers. The history of the universe is, in many ways, the history of galaxies. From their formation in the early universe to their continued evolution today, galaxies are the engines of cosmic creation, the sites where stars and planets are born, and the crucibles in which the elements necessary for life are forged. Stars, the life and death of cosmic giants. At the heart of every galaxy are stars, the fundamental building blocks of the universe. Stars are born from vast clouds of gas and dust, known as molecular clouds. These clouds are cold and dark, but over time, gravity causes them to collapse, forming dense regions known as protostars. As the pressure and temperature in the core of a protostar increase, nuclear fusion begins, and a star is born. Stars come in a wide variety of sizes and temperatures, from small, cool red dwarfs that can burn for tens of billions of years, to massive, hot blue giants that live fast and die young. The mass of a star determines its fate. Small stars burn their fuel slowly and live for a long time, while massive stars burn their fuel rapidly and die in spectacular supernovae. Supernovae are some of the most energetic events in the universe. When a massive star exhausts its nuclear fuel, its core collapses under the force of gravity, triggering a violent explosion that scatters the star's outer layers into space. These explosions are responsible for creating many of the elements we find on Earth, including the carbon in our bodies and the iron in our blood. In a very real sense, we are made of stardust. After a supernova, what remains of the star depends on its mass. For stars with a mass less than about 3 times that of the Sun, the core collapses into a neutron star, a small, incredibly dense object made almost entirely of neutrons. If the star is more massive, the core collapses into a black hole, a region of space where gravity is so strong that not even light can escape. Black holes, the enigmatic endpoints of stars. Black holes are among the most mysterious and fascinating objects in the universe. They represent the ultimate triumph of gravity, where the warping of space and time becomes so extreme that even the fundamental laws of physics begin to break down. At the center of a black hole lies a singularity, a point of infinite density where all the matter that fell into the black hole is compressed into an infinitely small space. Surrounding the singularity is the event horizon, the boundary beyond which nothing can escape. Once an object crosses the event horizon, it is lost to the black hole forever. The event horizon marks the point of no return, where the escape velocity exceeds the speed of light. Despite their name, black holes are not entirely black. In the 1970s, physicist Stephen Hawking showed that black holes can emit radiation, now known as Hawking radiation. This radiation is incredibly weak and is only significant for very small black holes, but it suggests that black holes are not completely isolated from the rest of the universe. Black holes come in a variety of sizes, from stellar mass black holes, which form from the collapse of massive stars, to supermassive black holes, which are found at the centers of most galaxies, including our own Milky Way. These supermassive black holes can have masses millions or even billions of times that of the Sun, and their origins are still a topic of active research. The structure of spacetime, Einstein's legacy. As we venture further into the depths of the universe, we must confront one of the most mind-bending aspects of reality, the nature of space and time itself. Before the early 20th century, space and time were thought to be separate entities. Space was a three-dimensional stage on which objects moved, and time was the steady progression of events. However, Albert Einstein's theory of relativity revolutionized our understanding of these concepts, merging them into a single, four-dimensional fabric known as spacetime. According to Einstein's general theory of relativity, massive objects like stars and planets warp the fabric of spacetime, much like a heavy object placed on a rubber sheet causes it to curve. This curvature of spacetime is what we perceive as gravity. Objects in motion follow the curves in spacetime, and this explains why planets orbit stars and why light bends near massive objects like black holes. Perhaps the most famous demonstration of the curvature of spacetime is the phenomenon of gravitational lensing. When light from a distant star or galaxy passes near a massive object, such as a galaxy cluster, the light is bent and focused, much like a lens. This effect allows us to observe objects that would otherwise be too faint or too distant to see. Gravitational lensing has become a powerful tool in modern astronomy, helping us to map the distribution of dark matter in the universe and to study the most distant galaxies in unprecedented detail. Einstein's theory also revealed a profound connection between space and time. They are not independent entities, but are intertwined. The presence of mass and energy affects the flow of time, causing it to pass more slowly in regions of strong gravitational fields. This effect, known as time dilation, has been confirmed by experiments and has real-world applications, such as in the Global Positioning System, GPS, where time differences between satellites in orbit and clocks on Earth must be accounted for to ensure accurate navigation. The implications of relativity extend even further. The theory predicts that nothing can travel faster than the speed of light, which imposes a fundamental limit on our ability to explore the universe. The finite speed of light means that when we look out into the cosmos, we are also looking back in time. The light from distant galaxies takes millions or even billions of years to reach us, so we see these galaxies not as they are today, but as they were in the distant past. In this sense, the universe is a vast time machine, offering us glimpses of its history. The quantum realm, the uncertainty of the microcosmos. While relativity governs the large-scale structure of the universe, another set of laws, those of quantum mechanics, dominates the microscopic realm. At the heart of quantum mechanics is the idea that, at the smallest scales, the universe behaves in ways that defy our everyday intuition. Particles can exist in multiple states at once, their positions and momenta are uncertain, and they can be entangled, meaning that the state of one particle is instantaneously connected to the state of another, even if they are separated by vast distances. The quantum world is a place of probabilities rather than certainties. For example, the Heisenberg uncertainty principle tells us that we can never know both the position and momentum of a particle with perfect accuracy. The more precisely we measure one, the less precisely we can measure the other. This fundamental limit is not due to any flaws in our measurement techniques, it is a fundamental property of nature. Quantum mechanics also introduces the concept of wave-particle duality, where particles such as electrons and photons exhibit both particle-like and wave-like behavior. In some experiments, particles behave as discrete entities, like tiny billiard balls. In others, they behave as waves, capable of interfering with one another. This duality lies at the heart of many of the mysteries of quantum mechanics, and it challenges our classical understanding of the nature of reality. Perhaps the most astonishing aspect of quantum mechanics is the phenomenon of quantum entanglement. When two particles become entangled, their states are linked in such a way that the measurement of one particle's state immediately determines the state of the other, no matter how far apart they are. This spooky action at a distance, as Einstein famously called it, has been experimentally confirmed and is now being harnessed in the development of quantum computers and quantum communication systems. Despite its bizarre and counterintuitive nature, quantum mechanics has proven to be one of the most successful theories in the history of science. It underpins much of modern technology, from transistors and lasers to MRI machines and smartphones. Moreover, quantum mechanics is essential to our understanding of the fundamental forces of nature, including electromagnetism and the strong and weak nuclear forces. Dark matter, the invisible scaffold of the universe. As we look out into the universe, we are confronted with a profound mystery: most of the matter in the universe is invisible. This so-called dark matter does not emit, absorb, or reflect light, making it undetectable by traditional telescopes. Yet we know it exists because of its gravitational influence on visible matter. Without dark matter, galaxies would not have enough mass to hold themselves together, they would fly apart under the influence of their own rotation. The nature of dark matter remains one of the great unsolved mysteries of modern cosmology. We know that it makes up about 27% of the universe's total mass energy content, far more than the ordinary matter that makes up stars, planets, and everything we can see. But what is dark matter made of? Is it composed of exotic particles that we have yet to discover? Or is it something even stranger, perhaps an indication that our understanding of gravity itself is incomplete? Various experiments around the world are attempting to detect dark matter particles directly, using underground detectors shielded from cosmic rays and other sources of interference. So far, these efforts have not yielded definitive results, but the search continues. In the meantime, astronomers continue to map the distribution of dark matter across the universe by studying its gravitational effects on galaxies and galaxy clusters. One of the most striking discoveries about dark matter is its role in shaping the large-scale structure of the universe. Simulations of the early universe suggest that dark matter formed vast filaments, creating a cosmic web that guided the formation of galaxies and galaxy clusters. These simulations, combined with observations, show that dark matter acts as the invisible scaffold upon which the visible universe is built. Without dark matter, the universe as we know it would not exist. Dark energy, the force behind cosmic expansion. As if the mystery of dark matter were not enough, astronomers have uncovered an even more perplexing phenomenon: the universe is not only expanding, but the rate of expansion is accelerating. This discovery, made in the late 1990s by studying distant supernovae, has led to the realization that some unknown force, dubbed dark energy, is driving this accelerated expansion. Dark energy is even more mysterious than dark matter. It appears to be a property of empty space itself, a kind of energy that permeates all of space and exerts a repulsive force, pushing galaxies apart. Unlike dark matter, which clumps together under the influence of gravity, dark energy seems to be evenly distributed throughout the universe. It makes up about 68% of the universe's total mass energy content, meaning that nearly 3/4 of the universe is dominated by a force we barely understand. The discovery of dark energy has profound implications for the fate of the universe. If the expansion of the universe continues to accelerate, galaxies will move farther and farther apart, and the universe will eventually become cold, dark, and empty, a scenario known as the Big Freeze. In this future, stars will burn out, galaxies will drift apart, and the universe will become a vast, dark expanse, devoid of life and structure. However, the nature of dark energy remains one of the greatest unsolved questions in physics. Is it a constant force, as suggested by Einstein's cosmological constant, or is it something more dynamic, perhaps related to the energy of the quantum vacuum? Some theories even suggest that dark energy could change over time, leading to different outcomes for the universe's future, such as a Big Rip, where the acceleration becomes so extreme that it tears apart galaxies, stars, planets, and eventually even atoms. The multiverse, beyond the observable universe. As we contemplate the mysteries of dark matter and dark energy, we are forced to confront an even more profound question: is our universe the only one? Recent developments in cosmology and theoretical physics have led to the idea that our universe may be just one of many in a vast multiverse. The concept of the multiverse arises from several different lines of inquiry. One comes from the theory of cosmic inflation, which suggests that our universe is just one bubble in a much larger, inflating space. In this view, other bubbles could exist, each with its own physical laws and constants. These other universes could be radically different from our own, with different forms of matter, forces, and even dimensions. Another possible origin of the multiverse comes from string theory, which posits that the fundamental building blocks of the universe are not point particles, but tiny, vibrating strings. String theory predicts the existence of multiple dimensions beyond the familiar 3 dimensions of space and one of time. Some versions of string theory suggest that there could be many different possible configurations of these extra dimensions, each corresponding to a different universe. While the idea of the multiverse is speculative, it has profound implications for our understanding of reality. If our universe is just one of many, then the conditions we observe, such as the strength of gravity, the mass of the electron, and the temperature of the cosmic microwave background, could be the result of random chance, rather than fundamental laws. In a multiverse, anything that can happen, does happen, somewhere. There could be universes where stars never form, universes where life emerges in forms we cannot imagine, and universes where the fundamental forces of nature are so different that nothing recognizable as matter exists at all. The multiverse also raises deep philosophical questions about the nature of existence. If there are infinite universes, what does that mean for our sense of uniqueness? Are there versions of ourselves living in other universes, making different choices and leading different lives? The multiverse challenges us to rethink our place in the cosmos, not just as inhabitants of a vast universe, but as part of a potentially infinite expanse of realities. Black holes, gateways to the unknown. Few objects in the universe capture the imagination like black holes. These enigmatic regions of space, where gravity is so intense that not even light can escape, challenge our understanding of the cosmos and push the boundaries of physics. To comprehend black holes is to delve into the mysteries of space, time, and matter, and to confront the limits of human knowledge. At their core, black holes are formed from the collapse of massive stars. When a star exhausts its nuclear fuel, gravity wins the battle against the pressure of fusion, causing the star to collapse inward. For stars with masses greater than about 3 times that of the Sun, this collapse does not stop at the formation of a neutron star. Instead, the core continues to collapse until it becomes a singularity, a point of infinite density in zero volume, where the known laws of physics break down. Surrounding the singularity is the event horizon, the boundary beyond which nothing can escape. Once something crosses the event horizon, it is lost to the black hole forever. The event horizon is not a physical surface, it is a region of space where the escape velocity exceeds the speed of light. For anything that crosses this threshold, the pull of gravity becomes inescapable. Despite their fearsome reputation, black holes are not cosmic vacuum cleaners that indiscriminately consume everything around them. An object must cross the event horizon to be captured by the black hole's gravity. A star or planet orbiting a black hole at a safe distance will continue to do so, just as it would orbit a regular star. In fact, if the Sun were replaced by a black hole of the same mass, Earth's orbit would remain unchanged, though, of course, the loss of sunlight would have catastrophic consequences for life. One of the most fascinating aspects of black holes is the way they warp space and time. According to general relativity, the intense gravitational field of a black hole stretches and distorts space, creating what is known as gravitational time dilation. Time moves more slowly in the strong gravitational field near a black hole than it does far away. To an observer falling into a black hole, time would appear to pass normally, but to a distant observer, the falling object would appear to slow down, approaching the event horizon asymptotically but never quite crossing it. This warping of spacetime leads to some of the most intriguing phenomena associated with black holes. For example, near the event horizon of a black hole, the curvature of spacetime is so extreme that light can become trapped in orbit around the black hole, forming what is known as the photon sphere. Inside the photon sphere, light can circle the black hole multiple times before escaping or being pulled in, creating strange optical effects. Black holes also have a profound influence on their surroundings. Many black holes are surrounded by disks of gas and dust, known as accretion disks, which are heated to extreme temperatures as they spiral inward. As the material in the accretion disk falls toward the black hole, it can release vast amounts of energy in the form of X-rays and other radiation. This process is so efficient that it can outshine entire galaxies, creating some of the brightest objects in the universe, active galactic nuclei and quasars. At the center of most large galaxies, including our own Milky Way, lies a supermassive black hole. These black holes, with masses millions or even billions of times that of the Sun, are thought to have formed early in the history of the universe and to have played a key role in the formation and evolution of galaxies. The supermassive black hole at the center of the Milky Way, known as Sagittarius A*, has a mass of about 4 million suns and exerts a powerful influence on the stars and gas in its vicinity. The information paradox, a clash between theories. One of the most profound challenges posed by black holes is the so-called information paradox. In classical physics, information about a system's state, its position, momentum, and other properties, is preserved over time, even if the system undergoes dramatic changes. However, when an object falls into a black hole, it seems that all information about its state is lost forever, hidden behind the event horizon. This loss of information violates a fundamental principle of quantum mechanics, which states that information cannot be destroyed. The information paradox was first brought to light by Stephen Hawking, who showed that black holes can emit radiation, now known as Hawking radiation. This radiation is caused by quantum fluctuations near the event horizon, where pairs of virtual particles are created and one of the particles falls into the black hole while the other escapes. Over time, this process causes the black hole to lose mass and eventually evaporate. The problem is that Hawking radiation carries no information about what fell into the black hole. If the black hole eventually evaporates, all the information about the objects that fell into it would be lost, violating the principle of unitarity in quantum mechanics. This contradiction between general relativity and quantum mechanics has sparked intense debate among physicists and remains one of the key unsolved problems in theoretical physics. Some proposed solutions to the information paradox suggest that information is somehow encoded in the Hawking radiation, though we do not yet understand how. Others suggest that the information is stored at the event horizon itself, in a kind of holographic encoding. This idea, known as the holographic principle, suggests that the entire three-dimensional volume of a black hole could be described by information encoded on its two-dimensional event horizon. This principle has profound implications for our understanding of space and time and is closely related to theories of quantum gravity and string theory. Wormholes, bridges through space-time. One of the most tantalizing predictions of general relativity is the existence of wormholes, hypothetical tunnels through spacetime that could, in theory, connect distant regions of the universe or even different universes. Wormholes are solutions to Einstein's field equations that describe regions of spacetime where the curvature is so extreme that two points in space are connected by a shortcut through a higher dimension. The concept of a wormhole was first proposed by Albert Einstein and his colleague Nathan Rosen in 1935, and such objects are sometimes referred to as Einstein-Rosen bridges. In principle, a wormhole could allow for faster-than-light travel between distant regions of space, or even time travel. However, the creation of a stable, traversable wormhole would require the existence of exotic matter with negative energy, which has yet to be discovered. While wormholes remain speculative, they have captured the imagination of both scientists and science fiction writers. If wormholes do exist, they could provide a means of interstellar or even intergalactic travel, allowing civilizations to explore distant parts of the universe without being limited by the speed of light. Some theories of quantum gravity suggest that wormholes may be related to quantum entanglement, the phenomenon where particles become connected in such a way that the state of one particle is instantly correlated with the state of another, no matter how far apart they are. This connection between entanglement and wormholes is still a subject of active research, but it hints at a deep and fundamental relationship between space, time, and information. The search for extraterrestrial life. Are we alone? As we explore the vast expanse of the universe, one question looms larger than almost any other: are we alone? The search for extraterrestrial life is one of the most profound scientific endeavors of our time, driven by the desire to understand whether life is a unique phenomenon on Earth or a common occurrence throughout the cosmos. For most of human history, the question of life beyond Earth was purely philosophical. But in recent decades, advances in astronomy, biology, and planetary science have transformed this question into a scientific one. The discovery of thousands of exoplanets, planets orbiting stars beyond our solar system, has revealed that planets are common throughout the galaxy. Some of these planets are Earth-like, with conditions that could potentially support life. The search for life beyond Earth takes many forms. One approach is to study the atmospheres of exoplanets for signs of life, such as the presence of oxygen, methane, or other molecules that could be produced by biological processes. This is the goal of missions like the James Webb Space Telescope, which is designed to study the atmospheres of distant exoplanets in unprecedented detail. Another approach is the search for microbial life within our own solar system. Mars, with its history of liquid water, is a prime target for this search. The discovery of ancient riverbeds, deltas, and lake beds on Mars suggests that the planet may have once had conditions suitable for life. The Mars rovers, including Curiosity and Perseverance, are actively searching for signs of past life, such as organic molecules or fossilized microorganisms. Other moons in the solar system, such as Europa and Enceladus, also offer tantalizing possibilities. Both moons have subsurface oceans beneath their icy crusts, and recent discoveries suggest that these oceans may be in contact with rocky cores, creating the conditions for hydrothermal vents, environments where life on Earth is thought to have originated. In addition to searching for microbial life, scientists are also engaged in the search for intelligent life. The search for extraterrestrial intelligence, SETI, uses radio telescopes to listen for signals from advanced civilizations. While no definitive signal has yet been detected, the search continues, driven by the possibility that somewhere, perhaps in a distant corner of the galaxy, another civilization is asking the same questions we are. The discovery of life beyond Earth would have profound implications for our understanding of biology, evolution, and the nature of life itself. It would also raise deep philosophical and ethical questions about our place in the universe and our responsibilities to other forms of life. If we are not alone, how should we approach contact with an alien civilization? Should we attempt to communicate, or remain silent? These are questions that humanity may one day have to face. The future of the universe, eternity awaits. As we peer into the distant future, we confront the ultimate fate of the universe. Will the cosmos continue to expand forever, eventually becoming cold, dark, and empty? Or will it collapse in a fiery end, returning to the singularity from which it began? The future of the universe depends on the balance between the forces that govern its expansion and the nature of dark energy. If dark energy remains constant, the universe will continue to expand at an accelerating rate, leading to a future in which galaxies move farther and farther apart. Over billions of years, stars will burn out, and the universe will enter a period known as the degenerate era, when only the remnants of stars, white dwarfs, neutron stars, and black holes, remain. Eventually, even these objects will disappear, leaving behind a cold, dark universe filled with a sparse, dilute gas of elementary particles. This scenario, known as the Big Freeze, is one possible future for the universe. In this future, the universe becomes a cold and lifeless place, where entropy increases to the maximum possible value, and all forms of structure and complexity break down. Another possibility is the Big Crunch, in which the expansion of the universe eventually reverses, causing all matter to collapse back into a singularity. This could lead to a cyclic universe, where each Big Bang is followed by a period of expansion, contraction, and another Big Bang. In this model, the universe is eternal, going through infinite cycles of creation and destruction. A more exotic possibility is the Big Rip, where dark energy becomes increasingly dominant, eventually tearing apart galaxies, stars, planets, and even atoms. In this scenario, the universe would end in a violent disintegration, with space-time itself being ripped apart. While we cannot yet know the ultimate fate of the universe, the study of cosmology offers us a glimpse into these possibilities, and it reminds us that we are part of a much larger story, a story that stretches across vast scales of space and time. The universe, in all its grandeur and mystery, invites us to explore, to question, and to wonder. The arrow of time, entropy, and the evolution of the cosmos. One of the most fundamental and perplexing aspects of the universe is the nature of time. While we are intimately familiar with time's passage in our daily lives, the steady tick of seconds and minutes, the relentless march from past to future, the deeper nature of time remains one of the great mysteries of physics. Why does time appear to flow in only one direction? Why do we remember the past but not the future? The answers to these questions are tied to a concept known as entropy, the measure of disorder or randomness in a system. The second law of thermodynamics tells us that in a closed system, entropy tends to increase over time. This principle is often paraphrased as the arrow of time because it provides a direction to the flow of time, from low entropy in the past to high entropy in the future. But why should this be the case? In the laws of physics that govern the behavior of particles, time is symmetric. There is nothing in these equations that distinguishes between past and future. So why does time, in our everyday experience, seem to flow in only one direction? The answer lies in the conditions of the early universe. At the moment of the Big Bang, the universe was in an incredibly low entropy state. It was hot, dense, and homogeneous, with very little disorder. As the universe expanded, it began to cool, and structures such as galaxies, stars, and planets began to form. These structures represent local decreases in entropy, but the overall entropy of the universe continues to increase as it ages. Eventually, in the far future, the universe may reach a state of maximum entropy, where no further changes are possible, a state known as heat death. The arrow of time is intimately connected to the expansion of the universe. As the universe expands, the amount of available space increases, allowing entropy to grow. But if the universe were to eventually collapse in a big crunch, time might reverse, and entropy would decrease. In such a scenario, it is conceivable that time could flow backward from our perspective, with the future becoming the past and vice versa. The nature of time also raises deep philosophical questions about the nature of reality. Is time an absolute, fundamental feature of the universe, or is it an emergent property that arises from more basic principles? Some physicists have suggested that time is not fundamental at all, but rather an illusion created by our perception of change. In this view, the universe may be more like a timeless block, where past, present, and future all exist simultaneously, and the flow of time is a product of our limited perspective. The anthropic principle, fine-tuning in the universe. As we delve deeper into the cosmos, we are confronted with a profound mystery. The universe appears to be remarkably fine-tuned for the existence of life. The constants of nature, such as the strength of gravity, the charge of the electron, and the speed of light, seem to be precisely calibrated in such a way that life, as we know it, is possible. If any of these constants were even slightly different, stars might not form, atoms might not hold together, and the complex chemistry needed for life would be impossible. This observation has led to the formulation of the anthropic principle, which suggests that the universe must be compatible with the existence of observers, like us, who can contemplate it. There are two main versions of the anthropic principle, the weak anthropic principle and the strong anthropic principle. The weak anthropic principle states that we should not be surprised to observe a universe that is finely tuned for life, because if the universe were not so, we would not be here to observe it. In other words, the fact that the universe permits life is not surprising, given that we are products of that universe. The strong anthropic principle, on the other hand, goes further by suggesting that the universe must be fine-tuned for life in some fundamental way, that the very existence of life is somehow necessary for the universe to exist as it does. Some interpretations of the strong anthropic principle suggest that the universe is designed or constrained in such a way that life is an inevitable outcome. One possible explanation for the apparent fine-tuning of the universe is the multiverse hypothesis. According to this idea, our universe is just one of many in a vast multiverse, each with its own set of physical laws and constants. In most of these universes, the conditions would not be suitable for life, but in a small subset of universes, the constants are just right for life to emerge. We happen to live in one of these life-friendly universes, not because of any special significance, but simply because it is the only kind of universe in which we could exist. Another possible explanation is that the constants of nature are not fixed, but vary over time or across different regions of the universe. In this view, life might be possible only in certain epochs or locations within the universe, while other parts of the cosmos remain inhospitable. The anthropic principle, while intriguing, remains a subject of debate among scientists and philosophers. It raises profound questions about the nature of existence, the role of chance in the universe, and the possibility of other forms of life that might exist under different physical laws. Ultimately, the fine-tuning of the universe may point to deep, underlying principles that we have yet to fully understand. Cosmic evolution, from simplicity to complexity. One of the most remarkable aspects of the universe is its capacity to evolve from simplicity to complexity. The early universe, in the moments after the Big Bang, was a hot, homogeneous sea of particles. Over time, as the universe expanded and cooled, these particles began to coalesce into more complex structures, first atomic nuclei, then atoms, then stars and galaxies. Within galaxies, stars forged the elements necessary for life, and on at least one planet, Earth, these elements combined to form living organisms, capable of self-replication, adaptation, and, eventually, consciousness. This process of cosmic evolution, the emergence of complexity from simplicity, is one of the great themes of the universe. It suggests that the cosmos is not static or unchanging, but a dynamic, evolving system, governed by the laws of physics but filled with potential for creativity and growth. The story of cosmic evolution can be divided into several key stages. The first stage, known as cosmological evolution, covers the formation of the universe itself, the Big Bang, the creation of the fundamental forces and particles, and the formation of the first galaxies and stars. This stage sets the stage for everything that follows, providing the raw materials and energy for the next stages of evolution. The second stage, stellar evolution, takes place within stars, where nuclear fusion transforms hydrogen into helium and other heavier elements. These elements are then scattered into space by supernovae, enriching the interstellar medium with the building blocks of planets and life. The third stage, planetary evolution, involves the formation of planets and moons from the dust and gas left over from star formation. On planets like Earth, complex chemistry takes place, leading to the emergence of life. This stage is closely tied to the conditions of the planet's environment, its temperature, its atmosphere, and its proximity to its star. The fourth stage, biological evolution, is the process by which life emerges and adapts to its environment. On Earth, this process has led to the incredible diversity of life we see today, from single-celled organisms to complex multicellular organisms, including humans. The final stage, cultural evolution, is unique to humans and other intelligent species. This stage involves the transmission of knowledge, ideas, and culture from one generation to the next, allowing societies to develop technologies, languages, and civilizations. Cultural evolution is driven not by biological adaptation, but by learning and innovation, and it has allowed humans to reshape the planet and explore the cosmos. Cosmic evolution is a story of increasing complexity, but it is also a story of fragility. The conditions that allow complexity to arise are rare and delicate, and the universe is filled with forces, from supernovae to black holes to cosmic radiation, that can easily destroy complex structures. Yet, despite these challenges, the universe has managed to produce a staggering array of complexity, from the smallest particles to the largest galaxy clusters, and from simple chemical compounds to self-aware beings capable of contemplating the cosmos. The search for meaning, humanity's place in the universe. As we gaze out into the vastness of the cosmos, we are inevitably confronted with questions of meaning and purpose. What does it mean to exist in a universe so vast and ancient? What is the role of humanity in this grand cosmic narrative? These are questions that have been asked by philosophers, theologians, and scientists for centuries, and they continue to inspire debate and contemplation. From one perspective, the universe appears indifferent to human existence. The laws of physics operate with cold precision, and the forces of nature are blind to our hopes, fears, and aspirations. We are but tiny specks on a small planet, orbiting an unremarkable star in a galaxy among billions. In the face of such immensity, it is easy to feel insignificant, to wonder whether our lives have any greater meaning or purpose. Yet, from another perspective, the very fact that we can ask these questions is extraordinary. We are part of the universe, made from the same atoms and particles that compose stars and galaxies. The elements in our bodies were forged in the hearts of ancient stars, and the processes that govern the cosmos are the same processes that govern our lives. In this sense, we are not separate from the universe, but deeply connected to it. Moreover, the emergence of life, and especially intelligent life, may be one of the rarest and most remarkable phenomena in the cosmos. The fact that we can reflect on the nature of existence, explore the mysteries of the universe, and even contemplate our own place in it suggests that humanity occupies a unique and significant role in the grand cosmic story. Carl Sagan famously said, "We are a way for the cosmos to know itself." In this view, human consciousness is not an accident or a trivial outcome of cosmic evolution, but a profound expression of the universe's potential. Through our exploration of science, art, and philosophy, we are participating in the universe's ongoing process of self-discovery. The search for meaning in the universe is ultimately a deeply personal and subjective endeavor. Some find meaning in the beauty and majesty of the cosmos, in the intricate patterns of nature, or in the pursuit of knowledge. Others find meaning in human relationships, in the bonds of love and friendship, or in the quest to improve the world. Still others look to religion or spirituality for answers to life's deepest questions. Whatever path we choose, the universe provides a vast and awe-inspiring context for our existence. It challenges us to think beyond ourselves, to consider the broader sweep of time and space, and to appreciate the fragile and precious nature of life. In the end, perhaps the greatest meaning we can find is the sense of wonder and curiosity that drives us to explore the cosmos, and the recognition that, for all its vastness, the universe is our home. The cosmic perspective, a humbling and enlightening view. Adopting a cosmic perspective is perhaps one of the most transformative shifts in human understanding. It requires us to step outside of our everyday concerns, to rise above the parochial and the immediate, and to view ourselves as part of a vast, interconnected web of existence that stretches across the universe. The cosmos is not merely a backdrop for human affairs, it is the stage upon which all life, all history, and all possibilities unfold. One of the great revelations of modern science is that the universe is incomprehensibly large and ancient. Our Earth, which once seemed to be the center of everything, is now understood to be a small, fragile world orbiting a medium-sized star in the outer reaches of an average galaxy. The Milky Way itself is but one of trillions of galaxies, each containing billions or even trillions of stars. And beyond the observable universe may lie even more, a vast, unknowable expanse that we can only imagine. This perspective can be both humbling and empowering. On the one hand, it forces us to confront our own insignificance in the grand scheme of things. The entire history of human civilization, from the first spark of fire to the dawn of the internet, is but a fleeting moment on the cosmic calendar. In the future, long after humanity is gone, the stars will continue to burn, galaxies will continue to drift through space, and the universe will continue to evolve. But the cosmic perspective also reveals something extraordinary. Despite the vastness of the universe, we are part of it. The same laws of physics that govern the motion of galaxies also govern the chemistry of life. The atoms in our bodies were forged in the hearts of stars billions of years ago. We are, quite literally, stardust. This realization, that we are connected to the universe in a profound and intimate way, can inspire a deep sense of awe and wonder. It can also give us a new sense of responsibility. If life on Earth is the only life in the universe, then it is incredibly rare and precious. We are the stewards of this tiny oasis of life, and it is up to us to protect and nurture it. The cosmic perspective also challenges us to think about the future. If we can survive the challenges of our present, from environmental degradation to geopolitical conflict, we may one day explore the stars. The universe is filled with possibilities, new worlds to discover, new forms of life to encounter, and new frontiers of knowledge to explore. The story of humanity is not yet written, and the future holds the promise of wonders beyond our current imagination. The search for extraterrestrial intelligence, listening to the stars. One of the most tantalizing possibilities raised by the cosmic perspective is the existence of intelligent life beyond Earth. Given the vast number of stars and planets in the universe, it seems unlikely that Earth is the only world to have produced life. But if there are other civilizations out there, why haven't we found them? This question, known as the Fermi paradox, has puzzled scientists for decades. The search for extraterrestrial intelligence, SETI, is a scientific effort to answer this question. Since the 1960s, scientists have been using radio telescopes to listen for signals from other civilizations. The basic idea is that an advanced civilization might use radio waves to communicate across the vast distances of space, just as we do. By scanning the sky for unusual signals, we might be able to detect evidence of intelligent life. So far, SETI has not found any definitive signals from other civilizations, but the search is still in its early stages. The universe is vast, and our ability to scan it is limited by the size and sensitivity of our telescopes. Moreover, intelligent civilizations might use communication methods that we have not yet discovered, or they might choose to remain silent. There are many possible explanations for the Fermi paradox. Perhaps intelligent life is extremely rare, and we are one of the first civilizations to emerge. Or perhaps civilizations tend to self-destruct before they can develop the technology for interstellar communication. Another possibility is that advanced civilizations are out there, but they are deliberately avoiding contact with us, much as we might avoid disturbing a primitive tribe in a remote jungle. Whatever the explanation, the search for extraterrestrial intelligence is one of the most profound scientific endeavors of our time. If we were to discover a signal from another civilization, it would forever change our understanding of our place in the universe. It would prove that we are not alone, that the universe is teeming with life, and that intelligent beings are out there, exploring the cosmos just as we are. The discovery of extraterrestrial intelligence would also raise deep ethical and philosophical questions. How should we respond to such a signal? Should we attempt to communicate, or would that be too dangerous? What would it mean for human culture, religion, and science to know that we are not the only intelligent beings in the universe? While these questions remain speculative, the search for extraterrestrial intelligence is a reminder that the universe is filled with possibilities, and that the future holds the potential for discoveries that could transform our understanding of existence. The nature of consciousness, the universe awakens. One of the most profound mysteries of the cosmos is the nature of consciousness itself. How is it that a collection of atoms, organized in the right way, can give rise to thoughts, emotions, and self-awareness? What is it about the brain, a 3-pound organ made of neurons and synapses, that allows us to experience the world subjectively? And could consciousness exist elsewhere in the universe, perhaps in forms radically different from our own? The study of consciousness has traditionally been the domain of philosophy, but in recent decades, it has become a major focus of scientific research as well. Neuroscientists have made great strides in understanding how the brain works, mapping the neural circuits responsible for perception, memory, and decision-making. Yet, the fundamental question of how these processes give rise to subjective experience, the so-called hard problem of consciousness, remains unresolved. Some scientists have suggested that consciousness may not be limited to biological organisms like humans and animals. It is possible that consciousness could emerge in other systems, such as advanced artificial intelligence or even complex networks of stars and galaxies. This idea, known as panpsychism, suggests that consciousness is a fundamental property of the universe, present in all matter to some degree. In this view, the universe itself could be thought of as awakening as it becomes more complex, with consciousness emerging as a natural part of the process of cosmic evolution. The nature of consciousness also has profound implications for our search for extraterrestrial life. If consciousness is not limited to biological life forms, it is possible that we could encounter intelligent beings that are not made of flesh and blood, but are instead composed of entirely different materials, perhaps even energy or electromagnetic fields. Such beings might experience reality in ways that are utterly alien to us, yet they could still possess self-awareness and intelligence. The question of consciousness is closely tied to the question of meaning. If consciousness is a fundamental feature of the universe, then our experience of the world, our thoughts, emotions, and dreams, may be an essential part of the cosmic story. Rather than being accidental byproducts of evolution, our minds could be part of a much larger, universal process of self-awareness. In the end, the nature of consciousness may hold the key to understanding not only ourselves but the universe as a whole. As we explore the cosmos, we are also exploring the nature of reality and the profound connections between mind and matter. The multiverse, infinite possibilities. As we contemplate the vastness of the universe, we must also consider the possibility that our universe is not the only one. The idea of the multiverse, a collection of many universes, each with its own physical laws and constants, has gained increasing attention in recent years, driven by developments in cosmology, quantum mechanics, and string theory. The concept of the multiverse arises from several different lines of inquiry. One of the most compelling comes from the theory of cosmic inflation, which suggests that the universe underwent a period of rapid expansion in the first moments after the Big Bang. This inflationary period could have produced not just one universe, but many, with each universe forming in a different bubble of space-time. These bubble universes could have different physical properties, leading to a vast diversity of possible worlds. Another source of the multiverse idea comes from quantum mechanics. In the standard interpretation of quantum theory, particles exist in a superposition of states until they are observed, at which point they collapse into a single state. But according to the many worlds interpretation of quantum mechanics, this collapse never actually happens. Instead, every possible outcome of a quantum event is realized in a separate branch of the universe. In this view, there are countless parallel universes, each representing a different outcome of every possible quantum event. String theory, which seeks to unify the fundamental forces of nature, also suggests the existence of multiple universes. String theory predicts the existence of extra dimensions beyond the familiar 3 dimensions of space and 1 of time. These extra dimensions could allow for the existence of different branes, or membranes, each representing a different universe. In this view, our universe is just one brane floating in a higher dimensional space, with other branes, other universes, existing nearby. The multiverse raises profound questions about the nature of reality. If there are infinite universes, does that mean that every possible version of events has happened somewhere? Are there other versions of ourselves living in different universes, making different choices and leading different lives? Could we one day travel between universes, exploring worlds with entirely different physical laws? While the multiverse remains speculative, it challenges us to think beyond the boundaries of our own universe. It suggests that the cosmos is even more vast and diverse than we ever imagined, filled with possibilities that stretch the limits of human understanding. The future of the cosmos, what lies ahead? As we look to the future, we are confronted with the ultimate question: what is the fate of the universe? Will the cosmos continue to expand forever, eventually becoming cold, dark, and lifeless? Or will it collapse in on itself, ending in a fiery, big crunch? These are the questions that cosmologists are attempting to answer as they study the nature of dark energy, the mysterious force that is driving the universe's accelerated expansion. One possibility is that the universe will continue to expand at an accelerating rate, driven by dark energy. In this scenario, known as the Big Freeze, galaxies will move farther and farther apart, and the universe will grow colder and more isolated. Stars will eventually burn out, leaving behind only the remnants of white dwarfs, neutron stars, and black holes. Over time, even these remnants will decay, leaving the universe a cold, dark void. Another possibility is that the expansion of the universe will eventually reverse, leading to a big crunch. In this scenario, the universe would collapse back in on itself, returning to a hot, dense state similar to the conditions of the Big Bang. This could lead to a cyclic universe, with repeated cycles of expansion and contraction, each ending in a new Big Bang. A more exotic possibility is the Big Rip, in which dark energy becomes increasingly dominant, eventually tearing apart galaxies, stars, planets, and even atoms. In this scenario, the universe would end in a violent disintegration, with space-time itself being ripped apart. While the ultimate fate of the universe remains uncertain, the study of cosmology offers us a glimpse into the future. It reminds us that the universe is a dynamic, evolving system, constantly changing over time. And while the future may hold challenges and uncertainties, it also holds the promise of new discoveries, new possibilities, and new frontiers. As we continue to explore the cosmos, we are also exploring the nature of existence itself. The universe, in all its vastness and complexity, invites us to ask the deepest questions: what is the nature of reality? What is our place in the cosmos? And what does the future hold for us, for life, and for the universe itself? Conclusion: our place in the universe. In the grand scheme of the universe, we are small. Our lives are fleeting, our planet is fragile, and our understanding of the cosmos is still in its infancy. Yet, in our brief moment of existence, we have achieved something extraordinary: we have begun to understand the universe. Through science, we have uncovered the laws that govern the cosmos, from the birth of stars to the behavior of particles at the smallest scales. We have sent spacecraft to other planets, peered into the depths of space with powerful telescopes, and contemplated the possibility of life beyond Earth. In the process, we have discovered that the universe is far more vast, complex, and mysterious than we ever imagined. We have learned that we are part of a cosmic story that stretches back billions of years and that will continue for billions more. We have come to understand that our planet is a small, fragile oasis in the midst of a vast and indifferent universe, but that it is also the only home we have. The cosmic perspective challenges us to think beyond ourselves, to recognize our place in the larger scheme of things. It reminds us that we are not the center of the universe, but a part of it. And it calls on us to protect our planet, to care for one another, and to continue exploring the mysteries of the cosmos. In the end, The greatest gift of the cosmic perspective is the sense of wonder and curiosity it inspires. The universe is filled with questions, and we are just beginning to scratch the surface. As we continue to explore, we will undoubtedly make new discoveries, uncover new mysteries, and gain new insights into the nature of reality. The journey is just beginning, and the future holds endless possibilities. The exploration of space, humanity's journey to the stars. The story of humanity's journey into space is one of the most remarkable chapters in the grand narrative of cosmic exploration. For most of our history, we were bound to the Earth, gazing at the stars with wonder but with no means to reach them. Our ancestors looked to the sky, crafting myths and legends about the heavens, dreaming of distant worlds that seemed forever out of reach. But in the 20th century, a new era began, an era in which human beings took their first tentative steps beyond the confines of our planet. The exploration of space is more than just a technological achievement, it is a profound expression of our desire to understand the universe and our place within it. It is the embodiment of our curiosity, our creativity, and our determination to push the boundaries of what is possible. As we launch spacecraft to distant planets, send probes beyond the solar system, and prepare for the day when humans will walk on Mars, we are writing the next chapter in the story of human discovery. The first steps toward space exploration were taken in the mid-20th century, during a time of intense geopolitical competition. The space race between the United States and the Soviet Union was driven by the desire for technological superiority, but it also captured the imagination of the world. In 1957, the Soviet Union launched Sputnik, the first artificial satellite, into orbit. This marked the beginning of the space age, a time when humanity would begin to explore not just the surface of the Earth but the vastness of space. In 1961, Yuri Gagarin became the first human to travel into space, orbiting the Earth aboard the Vostok 1 spacecraft. His journey was a milestone in human history, demonstrating that it was possible for humans to survive in space and return safely to Earth. Gagarin's flight was followed by a series of increasingly ambitious missions, culminating in one of the greatest achievements in human history, the Apollo 11 moon landing. On July 20, 1969, Neil Armstrong became the first human to set foot on another world. His words, "That's one small step for man, one giant leap for mankind," echoed across the planet, inspiring a generation of scientists, engineers, and dreamers. The Apollo missions demonstrated not only our technological prowess but also our ability to work together in pursuit of a common goal. For a brief moment, the world united in awe and wonder at the sight of humans walking on the surface of the moon. The moon, a stepping stone to the cosmos. The moon, our closest celestial neighbor, has always held a special place in human imagination. For millennia, it was a source of mystery and wonder, its phases guiding agricultural cycles and its light illuminating the night. But the Apollo missions transformed the moon from a distant object of myth into a tangible world, a place where humans could one day establish a permanent presence. The moon is more than just a destination, it is a stepping stone to the rest of the solar system. Its low gravity makes it an ideal base for launching missions to other planets, and its resources, such as water ice in the shadowed craters of its poles, could be used to support future human settlements. In recent years, interest in returning to the moon has grown, with both government space agencies and private companies planning missions to establish a sustainable presence on the lunar surface. The Artemis program, led by NASA, aims to return humans to the moon by the mid-2020s, with the goal of building a permanent lunar base. This base would serve as a hub for scientific research and as a launching point for future missions to Mars and beyond. The exploration of the moon will allow us to test new technologies, learn more about the history of the solar system, and prepare for the challenges of living and working on other worlds. But the moon is not just a scientific and technological destination. It is also a place of deep cultural significance. Throughout history, the moon has inspired artists, poets, and philosophers, who have seen in its pale light a reflection of the human soul. The return to the moon is not just a journey into space, it is a journey into the heart of what it means to be human. Mars, the next frontier. While the Moon is our closest neighbor, Mars has long been the ultimate goal of space exploration. As the fourth planet from the Sun, Mars is a cold, dry world with a thin atmosphere and a surface marked by ancient river valleys, vast deserts, and towering volcanoes. But beneath its harsh exterior, Mars holds the tantalizing possibility of life. For decades, scientists have speculated that Mars may have once had liquid water on its surface, and that microbial life could have existed there in the distant past, or might even exist today. Mars has captured the human imagination like no other planet. Its reddish hue and prominent place in the night sky have made it a symbol of war, passion, and mystery in many cultures. Today, Mars represents the next great challenge for human space exploration. The journey to Mars is not just a technical endeavor, it is a test of our ability to survive and thrive on a world that is both alien and familiar. NASA's Perseverance rover, which landed on Mars in 2021, is searching for signs of ancient life and collecting samples that will be returned to Earth by future missions. These missions will pave the way for human exploration, helping us understand the planet's geology, climate, and potential for supporting life. The ultimate goal is to send humans to Mars. This will be a monumental task, requiring new technologies for life support, transportation, and habitat construction. The journey to Mars will take several months, and astronauts will need to live and work on the planet's surface for extended periods. But the rewards of this mission are immense. Mars offers the opportunity to study another world up close, to learn about the history of the solar system, and perhaps even to find evidence of life beyond Earth. Mars also represents the future of human colonization. If we can establish a permanent presence on Mars, we will have taken the first step toward becoming a multiplanetary species. Colonizing Mars could provide a backup for humanity, ensuring the survival of our species in the event of a catastrophe on Earth. It could also open the door to the colonization of other planets, moons, and asteroids, allowing humanity to spread throughout the solar system. The outer solar system, a realm of giants and icy worlds. Beyond Mars lies the realm of the gas giants, Jupiter, Saturn, Uranus, and Neptune, and the icy worlds of the Kuiper Belt. These planets and their moons offer some of the most fascinating and mysterious environments in the solar system. Jupiter, the largest planet, is a gas giant with a turbulent atmosphere and a system of moons that includes Europa, an icy world with a subsurface ocean that may harbor life. Saturn, with its iconic rings, also has intriguing moons such as Titan, with its lakes of liquid methane, and Enceladus, which ejects plumes of water vapor into space. The exploration of the outer solar system has been one of the great triumphs of robotic space exploration. The Voyager missions, launched in the 1970s, gave us our first close-up views of the gas giants and their moons, revealing a diverse and dynamic array of worlds. More recent missions, such as the Galileo mission to Jupiter and the Cassini mission to Saturn, have deepened our understanding of these distant planets and their potential for supporting life. One of the most exciting discoveries in recent years is the presence of water in the outer solar system. Europa, Enceladus, and even Pluto are thought to have subsurface oceans beneath their icy crusts. These oceans are kept warm by the gravitational interactions between the moons and their parent planets, creating environments that could be hospitable to life. Future missions, such as NASA's Europa Clipper, will explore these icy moons in greater detail, searching for signs of life and studying their geology and chemistry. The outer solar system also holds the promise of new discoveries in planetary science and astrophysics. The gas giants are laboratories for studying the physics of planetary atmospheres, magnetic fields, and the formation of planetary systems. The Kuiper Belt, a region of icy bodies beyond Neptune, is home to objects that are remnants from the early solar system, providing a window into the processes that shape the planets. Beyond the solar system, the search for exoplanets. While the exploration of our own solar system is ongoing, one of the most exciting developments in recent years has been the discovery of exoplanets, planets orbiting stars beyond our solar system. Since the first confirmed detection of an exoplanet in 1992, thousands of these distant worlds have been discovered, ranging from gas giants larger than Jupiter to rocky planets similar in size to Earth. The search for exoplanets has transformed our understanding of planetary systems. It has shown that planets are common throughout the galaxy, and that many stars have planets orbiting in their habitable zones, where conditions might be right for liquid water and, potentially, life. Some of the most promising exoplanets, such as Proxima Centauri b and the TRAPPIST-1 system, lie within reach of future space missions that could study their atmospheres and search for signs of life. The discovery of exoplanets has raised profound questions about the possibility of life beyond Earth. If planets are common, and if many of them have conditions similar to those on Earth, then it seems likely that life could have arisen on other worlds. The search for life on exoplanets is one of the most exciting frontiers in modern science, and missions like the James Webb Space Telescope and the future LUVOIR mission will help us study the atmospheres of distant planets in unprecedented detail. The search for exoplanets also raises the possibility that we might one day travel to these distant worlds. While current technology makes interstellar travel impossible, advances in propulsion systems, such as ion drives and nuclear fusion, could one day allow us to explore the planets orbiting nearby stars. The dream of visiting other star systems is still far off, but the discovery of exoplanets has brought us one step closer to that future. The final frontier, humanity's future in the cosmos. As we continue to explore the solar system and beyond, we are confronted with the question of humanity's future in the cosmos. Will we remain confined to Earth, or will we become a spacefaring civilization, spreading out to other planets, moons, and star systems? The challenges of space exploration are immense, but so are the rewards. The exploration of space offers the opportunity to expand our knowledge, to ensure the survival of our species, and to fulfill the deepest human yearning for discovery. In the coming decades, we will face critical decisions about the future of space exploration. Will we prioritize the exploration of the Moon, Mars, or the outer solar system? Will we invest in the development of space habitats and space mining, opening the door to a new era of economic growth in space? Will we take the bold step of sending humans to Mars, beginning the process of establishing a permanent presence on another world? The future of space exploration will also raise profound ethical questions. As we explore and potentially colonize other planets, how should we treat these new environments? Should we protect them as natural preserves, or should we exploit their resources for the benefit of humanity? If we discover life on other planets, how should we interact with it? What are our responsibilities as stewards of the solar system? The answers to these questions will shape the future of space exploration and the destiny of humanity. As we stand on the brink of a new era in space, we have the opportunity to create a future that is bold, visionary, and inclusive, a future in which humanity reaches out to the stars and takes its place as a spacefaring species. In the end, the exploration of space is not just about technology or science, it is about who we are as a species. It is about our desire to understand the universe, to explore the unknown, and to seek out new possibilities for life and civilization. The cosmos beckons, and the future is ours to shape. The ethical challenges of space exploration, a new frontier for humanity. As humanity ventures further into space, we are faced with a new set of ethical dilemmas. Our reach extends beyond Earth, and with it comes the responsibility to consider the consequences of our actions on other worlds. These ethical challenges are not merely academic, they are practical concerns that will shape how we explore, inhabit, and interact with space. As we prepare for missions to Mars, the Moon, and even distant exoplanets, we must confront these ethical questions head-on to ensure that our exploration is responsible and respectful of the environments we encounter. One of the primary ethical concerns of space exploration is planetary protection. As we explore other worlds, we must take care not to contaminate them with life from Earth. This is especially important when it comes to places like Mars or the icy moons Europa and Enceladus, where conditions might be favorable for microbial life. If life exists on these worlds, even in microbial form, introducing Earth-based organisms could irreversibly alter their ecosystems, making it impossible to distinguish between native life and contamination from Earth. Planetary protection is not just about preserving the scientific value of these worlds, but also about respecting their inherent uniqueness. Each planet, moon, and asteroid in the solar system is a product of billions of years of cosmic evolution, and they represent environments that are vastly different from our own. Whether or not life exists on these worlds, they are important natural laboratories that hold clues to the history of the solar system and the processes that govern planetary formation. But planetary protection also raises difficult questions. How do we balance the need for exploration and potential colonization with the ethical responsibility to preserve these environments? Should we limit human presence on certain worlds to avoid contamination, or should we prioritize the search for resources and new habitats? The answers to these questions will require careful thought, guided by both scientific knowledge and ethical principles. The rights of extraterrestrial life, a moral imperative. Another profound ethical challenge arises from the possibility of discovering extraterrestrial life. If we find life beyond Earth, what moral obligations do we have toward it? Should we treat alien life forms, even microbial life, with the same respect and care that we accord to life on Earth? These questions become even more pressing if we discover intelligent extraterrestrial civilizations. The discovery of life on another planet would be one of the most transformative events in human history. It would fundamentally change our understanding of biology, evolution, and our place in the cosmos. But it would also raise complex ethical questions about how we interact with alien life. Would we have the right to alter or exploit extraterrestrial ecosystems for our own purposes, or should we protect them as we would protect endangered species on Earth? If we encounter intelligent life, the ethical challenges become even more complex. How should we communicate with an alien civilization? Should we approach them with caution, respect, and humility, or should we assert our own interests and goals? The history of human colonization on Earth is filled with examples of exploitation, conflict, and the destruction of indigenous cultures. We must learn from these mistakes as we consider how to engage with other intelligent beings in the universe. Some ethicists have suggested that we adopt a principle of cosmic stewardship, which holds that humanity has a responsibility to care for and protect life, wherever it is found. This principle would guide our interactions with extraterrestrial life, encouraging us to act as guardians of the cosmos, rather than conquerors. It would also prompt us to consider the long-term consequences of our actions, ensuring that we do not harm or disrupt ecosystems or civilizations that may be more fragile or less advanced than our own. The ethical use of space resources, balancing exploration and preservation. As humanity looks to the future of space exploration, one of the most exciting prospects is the potential to harness the vast resources of space. The asteroids, moons, and planets of the solar system contain a wealth of raw materials, from water ice to precious metals, that could be used to support human settlements and fuel space-based industries. Space mining could provide the resources needed to build habitats, manufacture goods, and sustain life on other worlds. But this raises significant ethical questions about the exploitation of space resources and the potential for environmental damage. The idea of space mining has sparked intense debate. On one hand, proponents argue that the resources of space are vast and largely untapped, offering a solution to many of the challenges facing Earth, such as resource depletion and environmental degradation. By moving heavy industry and resource extraction off Earth and into space, we could reduce the strain on our planet and preserve its ecosystems. Space mining could also open the door to economic growth and technological innovation, creating new opportunities for human advancement. On the other hand, critics warn that the rush to exploit space resources could lead to new forms of environmental degradation and inequality. Just as Earth has suffered from unsustainable resource extraction, there is a danger that space could be exploited in a similarly harmful way. The unregulated exploitation of asteroids or other celestial bodies could result in the destruction of unique environments and the depletion of resources that might be valuable for future generations. There are also questions about who has the right to claim and use space resources. International treaties, such as the Outer Space Treaty of 1967, declare that space is the province of all mankind, and that no nation can claim sovereignty over celestial bodies. However, the treaty is vague on the issue of resource extraction, and there is currently no comprehensive legal framework for governing space mining. This creates the potential for conflict and competition as nations and private companies vie for control of valuable resources. To address these concerns, many experts argue that we need a new set of international laws and regulations to govern the use of space resources. These laws should be based on principles of sustainability, equity, and environmental protection, ensuring that space exploration benefits all of humanity, rather than just a select few. They should also prioritize the preservation of celestial bodies, recognizing that these environments are unique and irreplaceable. The ethics of human colonization: who owns the stars? As humanity prepares for the possibility of colonizing other planets, we are faced with a fundamental ethical question: who owns the stars? Throughout history, the colonization of new lands on Earth has often been accompanied by claims of ownership, exploitation of resources, and conflict over territory. Will the same dynamics play out in space, or can we find a new way of thinking about colonization that is more inclusive, equitable, and sustainable? The idea of colonizing other planets, particularly Mars, has captured the public imagination. Private companies, such as SpaceX, have ambitious plans to establish human settlements on Mars within the next few decades. These plans envision self-sustaining colonies that could serve as a backup for humanity in case of disaster on Earth. But as we consider the practicalities of colonization, we must also grapple with the ethical implications. One of the central questions is whether humans have the right to claim ownership of other worlds. The Outer Space Treaty prohibits nations from claiming sovereignty over celestial bodies, but it is unclear how this applies to private companies or individuals. Should space be treated as a global commons, belonging to all of humanity, or should it be open to private ownership and exploitation? There is also the question of how we should approach the colonization of worlds that may have their own ecosystems or even life forms. If we discover microbial life on Mars or another planet, would it be ethical to establish human colonies there? Should we prioritize the preservation of alien ecosystems over human settlement, or should we assume that humanity's expansion into space is inevitable and necessary for our survival? The ethics of colonization also extends to the treatment of future space settlers. As we build colonies on other planets, we must ensure that these settlements are just, equitable, and inclusive. The history of colonization on Earth is filled with examples of exploitation, inequality, and environmental destruction. We must learn from these mistakes and strive to create space colonies that are fair, sustainable, and respectful of both human and non-human life. Space and the future of humanity, a shared destiny. Ultimately, the ethical challenges of space exploration force us to confront deeper questions about the future of humanity. As we venture into the cosmos, we must ask ourselves what kind of species we want to be. Will we be conquerors, driven by the desire to exploit new worlds for our own gain, or will we be stewards, guided by a sense of responsibility to protect and preserve the cosmos for future generations? The choices we make in the coming decades will shape the future of space exploration and the destiny of our species. If we approach space with a mindset of cooperation, sustainability, and respect for the environments we encounter, we have the potential to create a future that benefits all of humanity. If, on the other hand, we repeat the mistakes of the past, prioritizing short-term gains over long-term stewardship, allowing competition and conflict to dominate our interactions with space, we risk creating new forms of inequality and environmental degradation on a cosmic scale. The exploration of space is a profound opportunity to redefine what it means to be human. It challenges us to think beyond the borders of our planet, to consider the vastness of the universe and our place within it. It calls on us to act not just as citizens of Earth, but as citizens of the cosmos, with a responsibility to care for the environments we encounter and to ensure that the benefits of space exploration are shared by all. As we continue our journey into the cosmos, we must keep these ethical considerations at the forefront of our thinking. Space is a new frontier, filled with possibilities and challenges. It offers us the chance to explore, discover, and create a future that is bold and visionary. But it also calls on us to be thoughtful, responsible, and ethical in our actions. The stars are within our reach, but the way we reach them will determine whether we build a future of hope, justice, and sustainability, or one of conflict, exploitation, and environmental destruction. The choice is ours, and the future is waiting. The role of private companies in space exploration, a new era of innovation and responsibility. The rapid rise of private companies in space exploration marks a significant shift in how humanity approaches the cosmos. Historically, space exploration was the domain of government agencies like NASA, the European Space Agency, ESA, and the Soviet space program. These organizations, driven by national interests and scientific research, laid the groundwork for our understanding of space and achieved some of the most iconic milestones, such as landing humans on the Moon and sending probes to the outer planets. In recent years, however, private companies such as SpaceX, Blue Origin, and others have entered the field, bringing new energy, innovation, and ambition to space exploration. These companies are not only developing new technologies but also reshaping the very structure of how space exploration is conducted. With the advent of commercial spaceflight, we are entering an era where space is no longer the exclusive realm of government agencies, it is becoming a domain where private entities play a central role. The involvement of private companies has many potential benefits. Private companies often operate with greater flexibility and speed than government agencies, enabling them to innovate and test new technologies more quickly. SpaceX, for example, has revolutionized spaceflight by developing reusable rockets, dramatically reducing the cost of launching payloads into space. This has opened the door to more frequent and affordable space missions, potentially accelerating humanity's expansion into the cosmos. Private companies are also focusing on ambitious goals, such as the colonization of Mars and the establishment of commercial space stations. These goals, once considered science fiction, are now within the realm of possibility. SpaceX's Starship program aims to build a fully reusable spacecraft capable of carrying humans to Mars, while companies like Axiom Space are working on commercial space stations that could replace the International Space Station, ISS, as a hub for research and tourism. Yet the rise of private companies in space also raises important ethical and regulatory questions. Who will govern space exploration when private companies take the lead? What role will international cooperation play in an era of commercial spaceflight? And how can we ensure that the benefits of space exploration are shared by all of humanity, rather than being concentrated in the hands of a few wealthy individuals or corporations? Regulation and governance in the new space age. As private companies take on an increasingly prominent role in space exploration, there is an urgent need for new regulations and governance frameworks to ensure that space remains a peaceful, cooperative, and equitable domain. The existing legal framework for space, including the Outer Space Treaty of 1967, was designed during the Cold War and reflects an era when space exploration was primarily a state-driven endeavor. However, these treaties do not fully address the realities of modern space exploration, where private companies are launching rockets, mining asteroids, and planning missions to other planets. One of the key challenges is ensuring that space activities are conducted in a way that benefits all of humanity. The Outer Space Treaty declares that space is the province of all mankind, and that no nation can claim sovereignty over celestial bodies. However, as private companies begin to mine asteroids and establish colonies on other planets, there is a need for clearer guidelines on how resources in space can be used and who has the right to exploit them. Some experts have called for the establishment of an international regulatory body to oversee space activities, much like the International Maritime Organization governs the use of the world's oceans. Such a body could ensure that space is used sustainably, that environmental impacts are minimized, and that access to space is fair and equitable. It could also play a role in mediating disputes between nations and companies, ensuring that competition in space does not lead to conflict. Another important issue is the growing problem of space debris. As the number of satellites, rockets, and other objects in orbit around Earth increases, so too does the risk of collisions. Space debris poses a serious threat to both crewed and uncrewed missions, and if left unchecked, it could make certain orbits unusable. Private companies and governments alike must work together to develop strategies for cleaning up space debris and ensuring that space remains a safe environment for exploration and commerce. The commercialization of space, opportunities and risks. The commercialization of space presents both exciting opportunities and significant risks. On the one hand, private companies have the potential to unlock new economic opportunities in space, from space tourism and asteroid mining to satellite-based services and in-orbit manufacturing. These industries could create new jobs, drive technological innovation, and open up new markets, helping to fuel economic growth both on Earth and in space. Space tourism, in particular, has captured the public imagination. Companies like SpaceX, Blue Origin, and Virgin Galactic are developing spacecraft capable of carrying private citizens into space, offering the experience of weightlessness and a view of Earth from orbit. While space tourism is currently available only to the wealthy, the hope is that over time, costs will decrease, making space accessible to a wider range of people. Asteroid mining is another area of interest. The asteroids in our solar system contain vast quantities of valuable resources, including metals like platinum, gold, and nickel. Some estimates suggest that a single asteroid could contain more precious metals than have ever been mined on Earth. Mining these asteroids could provide the raw materials needed to build space habitats, fuel spacecraft, and support human colonies on other planets. However, asteroid mining also raises questions about sustainability, environmental impact, and the equitable distribution of resources. Despite these opportunities, there are also significant risks associated with the commercialization of space. One concern is that the pursuit of profit could lead to environmental degradation in space, just as it has on Earth. The unregulated extraction of resources from asteroids, moons, or other planets could result in the destruction of unique environments, with consequences that we do not yet fully understand. There is also the risk that space could become a new arena for inequality, with the benefits of space exploration concentrated in the hands of a few wealthy individuals or corporations. As private companies take the lead in space exploration, there is a danger that access to space, and the resources it offers, could become increasingly unequal, with wealthy nations and corporations gaining control over valuable assets while poorer nations are left behind. To mitigate these risks, it is essential that the commercialization of space is guided by ethical principles and international cooperation. Space exploration should not be driven solely by profit, it should also be guided by a commitment to sustainability, equity, and the shared benefit of all humanity. This will require new legal frameworks, stronger international cooperation, and a commitment to ensuring that space remains a peaceful and inclusive domain. The promise of space habitats, life beyond Earth. One of the most exciting prospects for the future of space exploration is the possibility of building space habitats, artificial environments where humans can live and work in space for extended periods of time. Space habitats could take many forms, from rotating space stations that simulate gravity to large, self-sustaining colonies on the Moon or Mars. The idea of space habitats has been a staple of science fiction for decades, but recent advances in technology are bringing this vision closer to reality. Companies like SpaceX, Blue Origin, and Axiom Space are already working on designs for space stations and habitats that could support human life in orbit or on other planets. These habitats could serve as bases for scientific research, hubs for space tourism, or even permanent settlements where humans live and work as they would on Earth. Space habitats have the potential to transform our relationship with space. By creating environments where humans can live comfortably and safely, they could allow us to establish a permanent presence in space, opening up new opportunities for exploration, commerce, and even culture. Over time, space habitats could become self-sustaining, with their own ecosystems, agriculture, and industries, making it possible for humans to live independently of Earth. The development of space habitats also raises important ethical and social questions. What kind of societies will we create in space? How will we ensure that space habitats are inclusive, equitable, and sustainable? As we establish new communities beyond Earth, we have the opportunity to rethink our social, political, and economic systems, building new models of governance and cooperation that are suited to the unique challenges of life in space. Space habitats also offer the possibility of creating new forms of culture and art. The experience of living in space, with its unique environment, perspectives, and challenges, could inspire new forms of creativity, leading to the development of space-based literature, music, visual arts, and even architecture. Just as human culture has been shaped by the environments of Earth, so too could it be shaped by the environments of space. The long-term future of space exploration, galactic civilization. As we look further into the future, we can imagine a time when humanity is no longer confined to the solar system, but has expanded to become a galactic civilization. This may seem like a distant and far-fetched dream, but the seeds of this future are being planted today, in the form of the technologies, institutions, and ethical frameworks that we are developing for space exploration. In the far future, humans could travel between stars, exploring distant planets, moons, and asteroids. Advances in propulsion technology, such as nuclear fusion, antimatter drives, or even theoretical concepts like warp drives, could make interstellar travel possible, allowing us to explore planets in other star systems. The discovery of exoplanets has shown us that planets are common in the galaxy, and it is likely that some of these worlds could support life, or even intelligent civilizations. Becoming a galactic civilization would represent the next stage in humanity's evolution, one in which we are no longer bound by the limitations of our home planet. It would allow us to spread our knowledge, culture, and values across the galaxy, creating new forms of civilization that are shaped by the unique environments and challenges of space. In doing so, we would fulfill one of the deepest human desires, the desire to explore, to discover, and to push the boundaries of what is possible. But the transition to a galactic civilization will not happen overnight. It will require decades, centuries, or even millennia of effort, cooperation, and innovation. It will also require a deep commitment to ethical principles, ensuring that our expansion into space is guided by a sense of responsibility, sustainability, and respect for the environments and life forms we encounter. Conclusion: a new cosmic era. Humanity stands at the dawn of a new cosmic era. The exploration of space, once the realm of science fiction, is becoming a reality, and the possibilities for the future are boundless. From the colonization of Mars to the discovery of life on distant exoplanets, from the rise of private space companies to the development of space habitats, the future of space exploration promises to be one of the most transformative periods in human history. But with these opportunities come responsibilities. As we venture into the cosmos, we must ensure that our actions are guided by ethical principles and a commitment to the shared benefit of all humanity. Space is not just a new frontier for exploration and commerce, it is a shared environment that we must protect and preserve for future generations. The choices we make today will shape the future of space exploration for centuries to come. Will we build a future of cooperation, sustainability, and shared progress, or will we repeat the mistakes of the past, allowing competition and exploitation to dominate? The answer will depend on our ability to think beyond short-term goals and to envision a future that is just, equitable, and inclusive. The cosmos is vast and filled with mysteries waiting to be uncovered. It challenges us to rise above our limitations, to think boldly, and to dream of what is possible. As we embark on this journey into the stars, we have the chance to create a new chapter in the story of humanity, one that is defined not by conflict and division, but by exploration, discovery, and a shared sense of wonder. The next generation of space technologies, transforming exploration and access. As humanity continues its journey into the cosmos, the development of new space technologies will play a critical role in shaping the future of space exploration. The technologies of today, from reusable rockets to advanced space telescopes, have already transformed our ability to explore the solar system and beyond. But the next generation of space technologies promises to revolutionize space travel, making it more accessible, sustainable, and capable of supporting long-term human presence on other worlds. One of the most significant technological advancements in recent years has been the development of reusable rockets. Traditionally, space rockets were single-use machines, discarded after launching their payloads into space. This made space exploration incredibly expensive, with each mission requiring the construction of a new rocket. However, companies like SpaceX and Blue Origin have pioneered the use of reusable rockets, which can be landed, refurbished, and launched again. This innovation has dramatically reduced the cost of launching payloads into space, opening the door to more frequent missions and the potential for space tourism, resource extraction, and colonization. Beyond reusable rockets, other propulsion technologies are also being developed to take humanity deeper into space. Ion propulsion, for example, uses charged particles to generate thrust, allowing spacecraft to travel at much higher speeds and with greater fuel efficiency than traditional chemical rockets. This technology has already been used in missions like NASA's Dawn spacecraft, which explored the asteroid belt, and is likely to be a key component of future missions to Mars and the outer planets. Nuclear propulsion is another promising technology that could revolutionize space travel. By harnessing the energy of nuclear reactions, spacecraft equipped with nuclear propulsion systems could travel much faster than those using chemical or ion propulsion. This would make interplanetary travel more feasible, reducing the time it takes to reach distant destinations like Mars or the moons of Jupiter and Saturn. In the long term, nuclear propulsion could also enable missions to other star systems, bringing us closer to the dream of interstellar exploration. In addition to advancements in propulsion, new technologies for space habitats are being developed that could support long-term human presence in space. Inflatable habitats, for example, offer a lightweight and expandable solution for building living quarters in space. These habitats can be launched in compact form and then inflated once in space, providing astronauts with more room to live and work. The Bigelow Expandable Activity Module, BEAM, currently attached to the International Space Station, is an early prototype of this technology, and future versions could be used to build space stations, lunar bases, or even habitats on Mars. Life support systems are another critical area of technological development. In order to establish permanent settlements on other planets, we need to develop systems that can provide astronauts with air, water, food, and waste management in a closed-loop environment. Advances in biotechnology, such as the development of synthetic photosynthesis or microbial reactors that recycle waste into usable resources, could help create self-sustaining ecosystems in space habitats. These systems will be essential for supporting human life on long-duration missions and for enabling colonization of other worlds. Artificial gravity is another technology that could dramatically improve the viability of long-term space missions. In the microgravity environment of space, astronauts experience a range of health problems, including muscle atrophy, bone density loss, and fluid shifts. By creating rotating habitats or spacecraft that generate centrifugal force, we could simulate the effects of gravity and help mitigate these health issues. Several designs for rotating space stations and spacecraft have been proposed, and research into artificial gravity is ongoing. Robotics and artificial intelligence, AI, will also play a key role in the future of space exploration. Robots are already being used to explore distant planets, moons, and asteroids, and AI is helping to analyze the vast amounts of data collected by space missions. In the future, robots and AI could work alongside human astronauts, performing tasks in hazardous environments or operating autonomously on long-duration missions. AI could also assist in navigation, mission planning, and resource management, making space exploration more efficient and safer. Artificial intelligence and space exploration, the rise of autonomous missions. Artificial intelligence, AI, has already begun to reshape the way we explore space, and its influence will only grow in the coming decades. AI-powered systems are enabling spacecraft and robots to operate more autonomously, reducing the need for constant human intervention and allowing missions to be carried out in more remote and challenging environments. This is especially important for deep space missions, where communication delays make real-time control from Earth impractical. One of the key advantages of AI in space exploration is its ability to process and analyze vast amounts of data in real time. Space missions generate enormous volumes of data, from high-resolution images of distant planets to detailed measurements of magnetic fields, radiation levels, and atmospheric composition. AI systems can quickly analyze this data, identifying patterns and anomalies that might otherwise go unnoticed by human researchers. This can lead to faster discoveries and more efficient use of limited resources. AI is also being used to control spacecraft and landers, allowing them to make autonomous decisions based on their surroundings. NASA's Mars rovers, such as Curiosity and Perseverance, use AI to navigate the Martian surface, avoiding obstacles and selecting the most promising sites for exploration. In the future, AI-powered systems could enable spacecraft to explore distant moons and asteroids without needing constant oversight from mission control. As we plan for more ambitious missions, such as human missions to Mars or robotic missions to the icy moons of the outer planets, AI will play an increasingly important role. AI-powered robots could be sent ahead of human astronauts to set up habitats, extract resources, or conduct scientific research. These robots could operate independently for months or even years, preparing the environment for human arrival. On long-duration missions, AI could assist astronauts with tasks such as navigation, equipment maintenance, and medical care, ensuring the success of the mission even in the face of unforeseen challenges. AI's ability to simulate complex systems and model potential outcomes will also be invaluable for mission planning. Before sending humans to Mars, for example, AI can simulate different mission scenarios, helping engineers to optimize flight paths, resource usage, and habitat designs. These simulations can take into account a wide range of variables, from weather patterns on Mars to the psychological well-being of astronauts, allowing mission planners to anticipate and mitigate potential risks. One of the most exciting possibilities for AI in space exploration is its potential to assist in the search for extraterrestrial life. AI-powered systems could analyze data from space telescopes, scanning for signs of biosignatures in the atmospheres of exoplanets or detecting unusual radio signals that might indicate the presence of intelligent civilizations. By processing this data more quickly and accurately than humans can, AI could help us make one of the most profound discoveries in the history of science, the discovery of life beyond Earth. The human factor, psychological and social challenges of space colonization. While the technological challenges of space exploration are immense, the psychological and social challenges of long-duration space missions and space colonization are equally significant. As humanity prepares for missions to Mars and beyond, we must consider not only how to keep astronauts physically healthy but also how to maintain their mental health and well-being. Space is an inherently isolating and confined environment. Astronauts on long-duration missions will spend months or even years in close quarters with only a few other people, cut off from the rest of humanity. Communication with Earth will be delayed by minutes or even hours, making real-time conversations impossible. The psychological effects of such isolation and confinement are still not fully understood, but they are likely to be profound. One of the major challenges of space missions is the risk of psychological stress, anxiety, and depression. Astronauts may experience feelings of loneliness, homesickness, or boredom, especially during the long transit times between Earth and distant destinations like Mars. The monotony of daily routines, the lack of fresh food and natural scenery, and the constant awareness of the dangers of space can take a toll on mental health. To address these challenges, space agencies are developing strategies to support the psychological well-being of astronauts. These include designing living spaces that are more comfortable and psychologically stimulating, providing astronauts with opportunities for physical exercise and recreation, and using virtual reality to simulate environments from Earth. Maintaining regular communication with family and friends, even if delayed, will also be important for mitigating feelings of isolation. Another significant challenge is group dynamics. In the confined environment of a spacecraft or space habitat, interpersonal conflicts can arise, and managing these conflicts will be crucial for the success of long-term missions. Space agencies are studying group dynamics in analog environments on Earth, such as underwater habitats and isolated research stations, to better understand how teams can function effectively under the stresses of space travel. As we move toward space colonization, social challenges will become even more complex. Space colonies will need to develop new social structures, cultures, and systems of governance that are suited to the unique environment of space. Questions about the rights and responsibilities of space settlers, the allocation of resources, and the management of conflict will need to be addressed. Colonies on Mars or other planets will also need to grapple with questions of identity. How will people born on Mars think of themselves? Will they see themselves as Martians, Earthlings, or something entirely new? The long-term psychological and social effects of living in space are still largely unknown. Will people be able to thrive in the low-gravity environments of the Moon or Mars? How will future generations, born and raised in space, adapt to life beyond Earth? These are questions that we will need to explore as we push the boundaries of human exploration. Space exploration and climate change, learning from the cosmos to save our planet. While space exploration takes us to distant planets and moons, it also offers us new perspectives on our own planet, Earth. The view of Earth from space, a small, fragile blue sphere floating in the darkness, has become an iconic symbol of our interconnectedness and our vulnerability. This overview effect, experienced by astronauts when they see Earth from orbit, has profound implications for how we think about our planet and our responsibilities to protect it. One of the most urgent challenges facing humanity today is climate change. The exploration of space can help us address this challenge in several ways. First, satellites in orbit around Earth provide critical data for monitoring the planet's climate. These satellites track changes in temperature, sea level, atmospheric composition, and ice coverage, helping scientists to understand the impacts of climate change and to develop strategies for mitigation and adaptation. Space exploration also offers new technologies that could be used to combat climate change. For example, solar power satellites, which collect solar energy in space and transmit it to Earth, could provide a clean and renewable source of energy, reducing our reliance on fossil fuels. Space-based carbon capture systems could help remove carbon dioxide from the atmosphere, while space habitats could serve as testbeds for sustainable living technologies that could be applied on Earth. But perhaps the most important contribution of space exploration to the fight against climate change is the perspective it offers. From space, we see that Earth is a single, interconnected system, where the actions of one nation or industry affect the entire planet. We also see that Earth is a finite and fragile environment, with limited resources and a delicate balance of ecosystems. This perspective can inspire us to take more responsible actions to protect our planet and to work together as a global community to address the challenges of climate change. The technologies we develop for space exploration, from closed-loop life support systems to renewable energy technologies, will not only help us survive in space but also offer solutions for living more sustainably on Earth. As we explore the cosmos, we have the opportunity to learn from our experiences and apply those lessons to the challenges we face at home. A new vision for the future, space exploration as a path to unity. As humanity ventures deeper into space, we are presented with an opportunity to redefine our vision for the future. Space exploration is not just about scientific discovery or technological advancement, it is also about our aspirations as a species. The journey into the cosmos offers us a chance to unite in a shared purpose, to work together as a global community, and to create a future that is more just, equitable, and sustainable. Throughout history, exploration has often been driven by competition and conflict. The space race of the 20th century, while achieving remarkable scientific and technological breakthroughs, was fueled by geopolitical rivalry. But the challenges of space exploration in the 21st century require a different approach, one based on cooperation, collaboration, and shared responsibility. International cooperation in space has already proven to be a powerful force for progress. The International Space Station, ISS, a joint project of NASA, Roscosmos, ESA, JAXA, and other space agencies, is a shining example of what can be achieved when nations work together toward a common goal. The ISS has been a platform for scientific research, technological innovation, and peaceful collaboration for over 2 decades, and it serves as a model for future international partnerships in space. As we look to the future, the exploration of space could become a unifying force for humanity. The challenges of establishing colonies on Mars, mining asteroids, and exploring distant star systems are too great for any one nation or company to tackle alone. By working together, we can pool our resources, share our knowledge, and develop new technologies that benefit all of humanity. Space exploration also has the potential to inspire a new sense of global identity. The overview effect experienced by astronauts reminds us that we are all citizens of a single planet, with a shared destiny. As we venture into the cosmos, we can carry this sense of unity with us, building a future that transcends borders and divisions. The journey to the stars is not just a scientific or technological endeavor, it is a journey of the human spirit. It challenges us to think beyond our immediate concerns, to dream of what is possible, and to work together to create a better future for ourselves and for future generations. As we continue to explore the cosmos, we must ensure that our actions are guided by ethical principles, a sense of responsibility, and a commitment to the shared benefit of all humanity. The future of space exploration is bright, and the possibilities are boundless. Together, we can reach for the stars and build a future that is bold, visionary, and filled with wonder. Space exploration and the search for meaning, a philosophical perspective. As we push the boundaries of space exploration, one of the most profound questions we face is not only scientific or technological in nature, but philosophical. What does it all mean? The human drive to explore, to venture beyond the known into the vast expanse of space, is driven by something deeper than the desire for knowledge or the pursuit of economic gain. It is, at its core, an existential quest, a search for meaning in an incomprehensibly vast and ancient universe. Since the dawn of humanity, we have looked to the stars and asked fundamental questions about our place in the cosmos. Are we alone? What is the nature of reality? What is the purpose of existence? These are not just scientific questions, they are deeply philosophical inquiries that have shaped human culture, religion, and art for millennia. The exploration of space offers a new way to engage with these questions, forcing us to confront the vastness of the universe and the limitations of our understanding. One of the most humbling realizations of space exploration is the sheer scale of the cosmos. Our solar system is but a tiny speck in a galaxy of hundreds of billions of stars, which in turn is just one of trillions of galaxies in the observable universe. The light we see from distant galaxies has traveled for billions of years to reach us, meaning that when we look out into the night sky, we are seeing the universe as it was in the distant past. The scale of the universe, both in terms of space and time, dwarfs our human existence and challenges our sense of significance. In the face of this immensity, it is easy to feel insignificant. The entire span of human history is but a blink of an eye compared to the age of the universe, and the Earth itself is a fragile, tiny world orbiting an unremarkable star. But space exploration offers us a different perspective. Instead of diminishing our importance, it highlights the uniqueness and beauty of life. The fact that we are conscious beings capable of reflecting on the universe, exploring it, and contemplating its mysteries is itself an extraordinary phenomenon. Some philosophers and scientists have argued that the universe is indifferent to human existence, that life on Earth is a mere accident of physics and chemistry, with no inherent meaning or purpose. In this view, meaning is something that we create for ourselves through our actions, relationships, and creative endeavors. The universe does not care about us, but we can find meaning in our own experiences, in the pursuit of knowledge, and in the quest to explore the unknown. Others, however, see in the vastness of the cosmos a deeper purpose or order. The apparent fine-tuning of the universe's physical constants, which allow for the existence of life, has led some to speculate that the universe may be designed or structured in such a way that life and consciousness are inevitable outcomes. This idea, sometimes referred to as the anthropic principle, suggests that the very existence of observers like us may point to a deeper connection between the universe and life. Space exploration forces us to confront these philosophical questions in new ways. As we explore other planets and moons, as we search for life beyond Earth, and as we contemplate the possibility of intelligent civilizations elsewhere in the galaxy, we are constantly reminded of how little we know about the universe and our place in it. The search for extraterrestrial life, in particular, raises profound questions about the nature of life and consciousness, the uniqueness of humanity, and the ethical implications of encountering other forms of life. If we were to discover life elsewhere in the universe, even simple microbial life on Mars or Europa, it would fundamentally change our understanding of biology and the conditions necessary for life. It would raise questions about the commonality of life in the universe and whether the development of intelligence and consciousness is an inevitable outcome of evolution. If, on the other hand, we discover that life is exceedingly rare, that Earth is the only planet in the galaxy to host life, it would place even greater importance on our responsibility to protect and preserve life on our home planet. The possibility of encountering intelligent extraterrestrial civilizations raises even deeper philosophical questions. How would the discovery of another intelligent species change our view of ourselves? Would we see ourselves as just one of many intelligent beings in a vast and diverse universe, or would we cling to a sense of human exceptionalism? The encounter with another civilization could force us to rethink our assumptions about intelligence, culture, morality, and even the nature of reality itself. The search for meaning in the cosmos is not limited to the scientific and philosophical realms. It also touches on spirituality and religion. For many people, space exploration evokes a sense of wonder and awe that is deeply connected to their spiritual beliefs. The vastness and complexity of the universe inspire feelings of reverence for the mysteries of existence and the beauty of creation. Some see the exploration of space as a way to connect with the divine, to understand the nature of God or the universe's purpose. Others see in the exploration of space a new form of spirituality, one that is not tied to traditional religious beliefs, but that emerges from the experience of wonder, curiosity, and awe. The overview effect experienced by astronauts, who see the Earth from space and are struck by its fragility and beauty, has been described as a kind of spiritual awakening, a profound realization of our interconnectedness with the planet and with all of humanity. This sense of cosmic connectedness can inspire a new sense of purpose and responsibility, encouraging us to care for our planet and to seek peace and understanding among all people. The search for extraterrestrial life, a cosmic revelation. One of the most compelling questions in the philosophy of space exploration is the possibility of extraterrestrial life. Are we alone in the universe, or is life common throughout the cosmos? The discovery of life beyond Earth would be one of the most profound scientific and philosophical revelations in human history, with far-reaching implications for our understanding of biology, evolution, and the nature of life itself. The search for extraterrestrial life is not just about finding alien organisms, it is also about understanding the conditions that make life possible and the processes that lead to its emergence. Scientists are exploring a wide range of environments in our own solar system, from the subsurface oceans of Europa and Enceladus to the ancient river valleys of Mars, in the hope of finding signs of life. At the same time, space telescopes like the James Webb Space Telescope are searching for biosignatures in the atmospheres of exoplanets, looking for evidence of life beyond our solar system. If we were to discover microbial life on another planet, it would revolutionize our understanding of biology. It would suggest that life can arise in a variety of environments and that the conditions for life may be more common than we previously thought. This discovery would also raise questions about the origin of life on Earth. Did life arise independently on multiple planets, or was it spread throughout the galaxy by meteorites or other cosmic processes? The discovery of intelligent extraterrestrial life would be an even more profound revelation. If we were to encounter a civilization capable of communication or even space travel, it would force us to confront questions about the nature of intelligence, consciousness, and culture. How would we communicate with beings whose biology, language, and worldview might be radically different from our own? What moral and ethical responsibilities would we have towards such a civilization, and how would our relationship with them change our view of ourselves? The discovery of extraterrestrial intelligence would also challenge our religious and philosophical beliefs. Many religious traditions place humanity at the center of creation, and the discovery of other intelligent beings could force a re-evaluation of these beliefs. Would we see ourselves as one of many intelligent species in a universe teeming with life, or would we cling to a sense of human uniqueness and exceptionalism? How would different cultures and religions interpret the discovery of alien civilizations, and what new spiritual or philosophical questions would arise? The search for extraterrestrial life is ultimately a search for meaning. Whether we find life or not, the quest itself forces us to confront the fundamental questions of existence. What is life? What is consciousness? What is the purpose of the universe? These are questions that have been asked for millennia, but space exploration gives us new tools and new perspectives with which to explore them. Humanity's destiny in the cosmos, exploring the infinite. As we look to the future, the exploration of space offers us the opportunity to redefine our destiny as a species. For most of human history, we have been bound to the Earth, our existence shaped by the limitations of our planet and our understanding of the universe. But as we venture into space, we are no longer confined by these limitations. The cosmos offers us the possibility of expanding our horizons, both literally and metaphorically, and of creating new futures for humanity that transcend the boundaries of Earth. The expansion of humanity into space is often framed in terms of survival, the idea that by establishing colonies on other planets, we can ensure the long-term survival of our species in the face of existential threats like climate change, asteroid impacts, or nuclear war. While these are legitimate concerns, space exploration also offers the possibility of something more, the chance to create new forms of civilization, new cultures, and new ways of thinking about what it means to be human. As we establish colonies on the Moon, Mars, and other planets, we will be faced with the opportunity to build societies from the ground up. These colonies could serve as laboratories for experimenting with new forms of governance, social organization, and economic systems. They could also be places where we rethink our relationship with nature, developing sustainable technologies and practices that allow us to live in harmony with our environment. The challenges of living in space will require us to innovate and adapt, and in doing so, we may discover new ways of solving the problems that have plagued human societies on Earth. Space exploration also forces us to think about the long-term future of humanity. The Earth will not last forever. In a few billion years, the Sun will expand into a red giant, making life on Earth impossible. Long before that, the planet will face other existential threats, from asteroid impacts to the eventual depletion of its resources. If humanity is to survive in the distant future, we must learn to live beyond the Earth, to spread out into the cosmos and to adapt to the challenges of space. But the exploration of space is not just about survival, it is also about discovery. The universe is filled with mysteries waiting to be uncovered, from the nature of dark matter and dark energy to the possibility of life on other planets. As we explore the cosmos, we will gain new insights into the fundamental forces that govern the universe and the processes that shape the evolution of galaxies, stars, and planets. We will also deepen our understanding of life, consciousness, and the nature of existence. In the end, the exploration of space is a journey of the human spirit. It is an expression of our deepest desires, the desire to explore, to understand, and to connect with something greater than ourselves. It is a quest for knowledge, for meaning, and for a sense of belonging in a universe that is vast, complex, and mysterious. As we venture into the cosmos, we carry with us the hopes and dreams of all humanity. We are the explorers, the dreamers, and the builders of a future that stretches beyond the horizon of our imagination. The universe is waiting, and the future is ours to shape. Space exploration as a catalyst for global unity, bridging divides for a common future. Space exploration presents humanity with not only scientific and technological challenges but also a unique opportunity to come together as a global civilization. The vastness of the cosmos transcends the borders, ideologies, and conflicts that have historically divided us. In the pursuit of exploring the universe, we are given the chance to unify as a species, pooling our collective knowledge, resources, and ambitions for a shared goal. This idea, that the exploration of space could act as a catalyst for global unity, carries both practical and symbolic power. One of the most compelling examples of international cooperation in space is the International Space Station, ISS, a multinational effort involving the space agencies of the United States, Russia, Europe, Japan, and Canada. For over 2 decades, the ISS has served as a symbol of peaceful collaboration, where astronauts from different countries live and work together in orbit. The ISS stands as a testament to what can be achieved when nations set aside their differences and work toward a common goal. It demonstrates that, even amid geopolitical tensions on Earth, space exploration can serve as a neutral ground where cooperation flourishes. As we look to the future of space exploration, the need for international collaboration will only grow. The challenges of returning humans to the Moon, sending astronauts to Mars, and exploring the outer planets are too great for any one nation or organization to tackle alone. These missions require the expertise, resources, and funding of multiple countries, as well as the coordination of private companies, scientists, engineers, and policymakers. International collaboration will not only make these missions possible but will also help ensure that the benefits of space exploration are shared by all humanity, rather than being monopolized by a few powerful nations or corporations. Moreover, space exploration offers a platform for addressing some of the most pressing global challenges, from climate change to resource scarcity. Satellites in orbit around Earth provide vital data for monitoring the planet's environment, tracking changes in the climate, and predicting natural disasters. By working together to harness the power of space-based technologies, nations can develop more effective strategies for mitigating the impacts of climate change and ensuring that resources are used sustainably. Space exploration can also serve as a unifying force by fostering a sense of shared purpose and identity. The overview effect experienced by astronauts, the profound realization of Earth's fragility and the interconnectedness of all life, has the potential to inspire a new sense of global citizenship. When viewed from space, the divisions that separate us, national borders, cultural differences, political ideologies, seem insignificant in the face of the larger reality of our shared existence on a small, blue planet in the vastness of the universe. This perspective can help to shift our priorities, encouraging us to focus on what unites us rather than what divides us. By embracing the cosmic perspective, we can cultivate a spirit of collaboration and compassion, working together to solve the challenges we face as a global society. Space exploration provides a powerful metaphor for this kind of unity. Just as astronauts must work together in the confined environment of a spacecraft, so too must humanity work together to ensure the survival and flourishing of life on Earth. The ethical responsibilities of becoming a spacefaring civilization. As we stand on the cusp of becoming a spacefaring civilization, we must also confront the ethical responsibilities that come with this new chapter in human history. The exploration and colonization of space raise profound moral questions about our relationship with other worlds, the environments we encounter, and the potential life forms we may discover. How we choose to explore space, and how we interact with the cosmic environments we encounter, will shape not only the future of space exploration but also the future of humanity. One of the most pressing ethical concerns is the potential for environmental degradation in space. Just as industrial activities on Earth have led to pollution, deforestation, and the destruction of ecosystems, there is a risk that human activities in space could harm the environments of other planets, moons, and asteroids. Space mining, for example, has the potential to disrupt the surfaces of asteroids and other celestial bodies, stripping them of their resources and leaving them scarred by human intervention. The unregulated exploitation of space resources could lead to environmental destruction on a cosmic scale, with consequences that we cannot yet fully predict. To prevent such outcomes, it is essential that space exploration is guided by principles of environmental stewardship and sustainability. Just as we have developed environmental regulations to protect the ecosystems of Earth, we must create frameworks for the responsible use of space resources. This means not only minimizing our impact on the environments we encounter but also ensuring that the benefits of space exploration are shared equitably, rather than being concentrated in the hands of a few powerful corporations or nations. Planetary protection is another critical ethical issue. As we explore planets like Mars, Europa, and Enceladus, places that may harbor microbial life, we must take care to avoid contaminating these environments with life from Earth. The introduction of Earth-based microbes to another world could disrupt or destroy native ecosystems, making it impossible to study them in their natural state and potentially wiping out any indigenous life forms before we even discover them. This would not only be a scientific tragedy but also a moral failure, as it would demonstrate a lack of respect for the intrinsic value of life, wherever it may be found. The potential discovery of extraterrestrial life raises even deeper ethical questions. If we encounter life beyond Earth, what responsibilities do we have toward it? How should we treat alien organisms, even if they are as simple as bacteria? Should we prioritize the protection of these life forms and their ecosystems over human exploration and colonization? And if we discover intelligent extraterrestrial civilizations, how should we interact with them? These questions challenge us to rethink our assumptions about the value of life and the nature of moral responsibility on a cosmic scale. As we prepare for the possibility of colonizing other planets, we must also consider the ethical implications of space settlement. Colonizing a planet like Mars will require significant alterations to its environment, including the introduction of life support systems, the extraction of resources, and potentially even the terraforming of the planet to make it more hospitable for human life. While these actions may be necessary for human survival, they also raise questions about our right to alter the environments of other worlds. Do we have the moral right to reshape a planet to suit our needs, or should we seek to preserve its natural state as much as possible? These ethical considerations are not abstract or hypothetical, they are real issues that we will need to address as we continue our journey into space. How we choose to explore the cosmos will reflect our values as a civilization and will have lasting consequences for future generations. It is up to us to ensure that we approach space exploration with humility, respect, and a commitment to the responsible stewardship of the environments and life forms we encounter. The role of education and public engagement in shaping the future of space exploration. As humanity embarks on its journey into space, it is essential that we engage the public in the process of exploration and discovery. Space exploration is not just the domain of scientists, engineers, and astronauts, it is a shared endeavor that belongs to all of humanity. By fostering a sense of curiosity, wonder, and excitement about space, we can inspire the next generation of explorers, innovators, and thinkers who will shape the future of space exploration. Education plays a critical role in this process. By incorporating space science and astronomy into school curricula, we can give students the tools they need to understand the universe and their place in it. Space education not only teaches students about planets, stars, and galaxies but also encourages critical thinking, problem-solving, and creativity. It helps students develop a sense of wonder about the natural world and fosters a desire to explore the unknown. Public engagement is equally important. Space exploration has the power to captivate the public imagination, inspiring people of all ages and backgrounds to dream of what is possible. By sharing the stories of space missions, the discoveries of space telescopes, and the experiences of astronauts, we can bring the excitement of space exploration to a broader audience. Social media, documentaries, public lectures, and interactive exhibits can all play a role in making space exploration accessible and engaging for the general public. Citizen science projects, where members of the public can participate in scientific research, are another powerful way to engage people in space exploration. Projects like Galaxy Zoo, where volunteers help classify galaxies, or SETI at Home, where participants analyze radio signals in the search for extraterrestrial intelligence, give people the opportunity to contribute to real scientific discoveries. These initiatives not only democratize science but also create a sense of connection between the public and the broader scientific community. Engaging the public in space exploration is not just about inspiring curiosity, it is also about fostering a sense of ownership and responsibility. Space exploration is a shared endeavor that belongs to all of humanity, and the decisions we make about how we explore space will have global implications. By involving the public in discussions about the future of space exploration, we can ensure that these decisions are made in a way that reflects the values and aspirations of people around the world. Moreover, public support for space exploration is essential for securing the funding and political will needed to carry out ambitious missions. Space exploration is a long-term endeavor, often requiring decades of planning, development, and execution. By building a broad base of public support, we can ensure that space exploration remains a priority for governments and private organizations alike, even in the face of competing demands for resources and attention. The vision of a multiplanetary future, expanding the human presence in the cosmos. As we contemplate the future of space exploration, one of the most exciting possibilities is the vision of humanity becoming a multiplanetary species. This idea, championed by visionaries like Elon Musk, envisions a future in which humans live not only on Earth but also on other planets, moons, and space habitats throughout the solar system. This vision is driven by both practical and philosophical considerations, the need to ensure the long-term survival of humanity and the desire to explore new frontiers and expand the reach of human civilization. The colonization of Mars is often seen as the first step toward realizing this vision. Mars, with its relatively mild climate, abundant resources, and potential for supporting life, is the most viable candidate for human settlement beyond Earth. Establishing a colony on Mars would be a monumental achievement, requiring new technologies for transportation, life support, and habitat construction. It would also require careful planning and international cooperation to ensure that the colony is sustainable, self-sufficient, and environmentally responsible. But Mars is just the beginning. The moons of Jupiter and Saturn, such as Europa, Ganymede, and Titan, offer intriguing possibilities for future exploration and settlement. These icy worlds may contain subsurface oceans, and they could serve as bases for scientific research or even as homes for future colonies. Asteroids, too, could be mined for resources, providing the raw materials needed to build space habitats and support human life in space. The long-term vision of a multiplanetary future goes beyond the colonization of individual planets. It envisions the creation of space habitats, large, self-sustaining structures in space where humans can live and work for extended periods. These habitats could be located in orbit around Earth, the Moon, or other planets, and they could serve as hubs for research, industry, and tourism. In the distant future, these space habitats could even become independent colonies, forming the basis of new civilizations in space. The vision of a multiplanetary future is not just about survival, it is about expansion, exploration, and discovery. It is about pushing the boundaries of what is possible and embracing the challenges of living in new and unfamiliar environments. It is about creating new opportunities for human creativity, innovation, and culture, and about finding new ways to thrive in the cosmos. But this vision also raises important questions about the values and principles that will guide humanity's expansion into space. Will we approach space with a sense of stewardship, respecting the environments and life forms we encounter, or will we repeat the mistakes of the past, prioritizing exploitation over sustainability? Will we build inclusive, equitable societies in space, or will we allow inequality and conflict to shape our future among the stars? These are questions that we must confront as we embark on the journey to become a multiplanetary species. Conclusion: the cosmic destiny of humanity. The exploration of space represents one of the greatest adventures in human history. It challenges us to push the boundaries of our knowledge, to confront the unknown, and to reimagine our place in the universe. As we venture into the cosmos, We are not just seeking new frontiers, we are seeking new possibilities for the future of humanity. Space exploration offers us the opportunity to expand our horizons, both literally and figuratively. It allows us to see the world from a new perspective, to appreciate the fragility and beauty of our planet, and to understand the interconnectedness of all life. It also invites us to dream of a future that transcends the limitations of our present, a future where humans live and thrive on multiple planets, exploring the mysteries of the universe and creating new forms of civilization. But the journey into space is not just a technological or scientific endeavor, it is a moral and philosophical one. It challenges us to consider the ethical implications of our actions, to reflect on our responsibilities as stewards of the cosmos, and to ensure that the benefits of space exploration are shared by all of humanity. As we look to the future, we must approach space exploration with a sense of humility, wonder, and responsibility. The universe is vast and filled with mysteries waiting to be uncovered, but it is also fragile and precious. How we choose to explore the cosmos will define the legacy we leave for future generations. In the end, the exploration of space is not just about reaching new worlds, it is about understanding our place in the universe and our shared destiny as a species. The stars beckon, and the future is ours to create. The dawn of the space age, a turning point in human history. The exploration of space has often been described as humanity's next great leap, but it is more than that. It represents a turning point in human history, a moment when we transition from a species bound to one planet to a civilization that looks to the stars for its future. The space age, which began with the launch of Sputnik in 1957 and has continued through the Apollo moon landings, the International Space Station, and the Mars rovers, is a testament to human ingenuity, ambition, and our insatiable curiosity about the universe. As we stand at the threshold of the next phase of space exploration, it is worth reflecting on what the space age means for humanity. It is not just a series of technological milestones or scientific discoveries, it is a cultural and existential shift that has changed the way we think about ourselves and our place in the cosmos. The first images of Earth from space, captured by early satellites and astronauts, gave us a new perspective on our planet, a fragile, beautiful world suspended in the vastness of space. This view of Earth as a single, interconnected system, where national borders disappear and all life is part of a shared ecosystem, has had a profound impact on our understanding of global responsibility. The space age has also sparked a new era of scientific discovery. Our missions to the Moon, Mars, and beyond have taught us more about the history of our solar system, the nature of planets and moons, and the processes that shape the evolution of worlds. Space telescopes like the Hubble Space Telescope have expanded our vision of the universe, revealing distant galaxies, black holes, and exoplanets orbiting stars far beyond our solar system. These discoveries have deepened our understanding of the cosmos and our place within it, but they have also raised new questions that drive us to explore further. Looking back at the achievements of the space age, it is clear that we are just beginning to unlock the mysteries of the universe. The technology that took us to the moon more than 50 years ago was primitive by today's standards, yet it opened the door to a future filled with possibility. The space age is not over, in many ways, it is just beginning. As we develop new technologies and set our sights on more distant destinations, we are entering a new phase of exploration, one that could define the future of humanity for centuries to come. The role of innovation, pushing the boundaries of technology and imagination. At the heart of the space age is innovation, the relentless drive to push the boundaries of technology and imagination in the pursuit of exploration. Space exploration has always required us to think creatively, to solve complex problems, and to develop new technologies that allow us to overcome the challenges of space. From the development of rockets capable of reaching orbit to the creation of life support systems that can sustain astronauts in space, innovation has been the key to unlocking the mysteries of the cosmos. One of the most important areas of innovation in space exploration is propulsion technology. The rockets that took humans to the moon in the 1960s were marvels of engineering, but they were limited by the constraints of chemical propulsion. Today, we are developing new propulsion technologies that could make space travel faster, more efficient, and more accessible. Nuclear propulsion, for example, could reduce the travel time to Mars from several months to just a few weeks, making human missions to the red planet more feasible. Other technologies, such as ion propulsion and solar sails, offer the potential for long-duration missions to the outer planets and beyond. In addition to propulsion, innovation in spacecraft design is transforming the way we explore space. Reusable rockets, pioneered by companies like SpaceX, have dramatically reduced the cost of launching payloads into space, making it possible to conduct more frequent missions and to develop new commercial applications for space. Inflatable habitats, which can be launched in compact form and expanded in space, offer new possibilities for building space stations and colonies on other planets. Advances in robotics, artificial intelligence, and autonomous systems are enabling us to explore environments that are too dangerous or remote for human astronauts. But innovation in space exploration is not limited to technology, it also involves new ways of thinking about exploration itself. As we venture farther into space, we must rethink our strategies for exploring planets, moons, and asteroids. Traditional methods of exploration, such as sending large spacecraft with fixed missions, are being complemented by new approaches that emphasize flexibility, adaptability, and collaboration. Swarm robotics, for example, involves deploying fleets of small, autonomous robots that can work together to explore a planet's surface, conduct experiments, and gather data. This approach allows for more efficient exploration and can adapt to changing conditions on the ground. Innovation is also driving the rise of private space companies, which are playing an increasingly important role in space exploration. Companies like SpaceX, Blue Origin, and Virgin Galactic are developing new technologies for space tourism, satellite deployment, and even space colonization. These companies are not just competing with traditional government space agencies, they are partnering with them, creating new opportunities for collaboration and expanding the possibilities for exploration. The involvement of the private sector in space exploration is helping to democratize access to space, making it possible for more people and organizations to participate in the journey to the stars. The new frontier, space tourism and commercialization. One of the most exciting developments in recent years has been the emergence of space tourism and the commercialization of space. For decades, space travel was the exclusive domain of government astronauts, but that is beginning to change. Private companies are now developing spacecraft that can carry civilians into space, offering a glimpse of what it is like to orbit the Earth or experience weightlessness. Space tourism is still in its infancy, but it represents a significant step toward making space more accessible to the general public. The commercialization of space extends beyond tourism. Companies are exploring new ways to use space for economic purposes, from satellite-based services to asteroid mining. Space-based solar power, which involves collecting solar energy in space and transmitting it to Earth, could provide a new source of renewable energy. In-orbit manufacturing, where products are built in the zero-gravity environment of space, offers the potential to create materials and technologies that cannot be produced on Earth. Space commercialization also raises important ethical and regulatory questions. As more private companies enter the space industry, it is essential to establish clear rules and guidelines for the use of space resources, the protection of space environments, and the sharing of the benefits of space exploration. The commercialization of space offers great opportunities, but it also comes with risks, particularly if it leads to the exploitation of resources without regard for environmental sustainability or international cooperation. Nevertheless, the rise of space tourism and commercialization is a sign that space is becoming more integrated into our daily lives. The technologies developed for space exploration are already being used to improve life on Earth, from satellite-based communications to medical technologies. As we continue to explore space, we are likely to see even more innovations that benefit both space exploration and life on Earth. The future of space colonization, living beyond Earth. As we look to the future of space exploration, one of the most ambitious goals is the colonization of other planets. While missions to the Moon and Mars are currently focused on exploration, the long-term vision is to establish permanent human settlements on these worlds. Space colonization is no longer the realm of science fiction, it is a serious goal that is being pursued by space agencies and private companies alike. Mars is the most likely candidate for the first human colony. Its relatively mild climate, the presence of water ice, and its proximity to Earth make it a viable location for human settlement. Establishing a colony on Mars would be a monumental achievement, but it would also present significant challenges. The thin atmosphere, low temperatures, and high levels of radiation on Mars would require the development of advanced life support systems, habitats, and technologies for growing food and producing energy. In addition, transporting people and supplies to Mars would require significant advances in space transportation. The colonization of Mars could serve as a model for the colonization of other worlds in the solar system. The moons of Jupiter and Saturn, such as Europa and Titan, offer intriguing possibilities for future exploration and settlement. These icy moons may contain subsurface oceans that could harbor life, and they could serve as outposts for scientific research or as stepping stones for missions to the outer planets. Asteroids, too, could be mined for resources, providing the raw materials needed to build space habitats and sustain human life in space. Space colonization is not just about survival, it is about creating new opportunities for human civilization. Living on other planets would require us to develop new technologies, social structures, and ways of thinking about life. It would challenge us to adapt to new environments, to rethink our relationship with nature, and to build societies that are sustainable, equitable, and inclusive. But space colonization also raises important ethical questions. Do we have the right to alter the environments of other planets to suit our needs? Should we prioritize the preservation of extraterrestrial ecosystems, even if it means limiting human expansion? How can we ensure that the benefits of space colonization are shared by all of humanity, rather than being concentrated in the hands of a few powerful nations or corporations? These are questions that we must address as we move forward with plans for space colonization. Humanity's cosmic journey, from Earth to the stars. The exploration of space is more than just a scientific or technological endeavor, it is a journey of discovery, imagination, and possibility. It challenges us to think beyond the boundaries of our planet, to confront the mysteries of the universe, and to envision new futures for humanity. As we continue this journey, we are not just exploring new worlds, we are exploring new possibilities for ourselves and our civilization. Space exploration invites us to dream of what is possible. It encourages us to imagine a future where humans live and work on multiple planets, where we have harnessed the energy and resources of the solar system, and where we are exploring the stars beyond. This vision of the future is not just a distant fantasy, it is a goal that is within our reach, if we are willing to invest in the technologies, policies, and ethical frameworks that will make it possible. The journey to the stars is a journey of hope, wonder, and possibility. It is a testament to the human spirit, our curiosity, our creativity, and our desire to explore the unknown. As we continue to venture into space, we carry with us the dreams and aspirations of all humanity. The universe is vast and filled with mysteries waiting to be uncovered, and the future of space exploration holds endless possibilities. Humanity's place in the cosmos, a new understanding of ourselves. As humanity continues its journey into space, we are not only discovering new worlds, but also gaining new insights into our own nature. The exploration of space challenges us to think about what it means to be human in a vast and complex universe. The farther we travel, the more we come to understand the fragility of life, the interconnectedness of all living things, and the profound mystery of existence itself. In the past, our understanding of the cosmos was limited to the visible sky, the stars, the planets, and the sun. The ancient civilizations used the heavens as a guide for navigation, agriculture, and spirituality, creating myths and stories that explain the motions of the celestial bodies. Today, our knowledge of the universe has expanded beyond anything those early astronomers could have imagined. We have sent spacecraft to the outer planets, landed rovers on Mars, and looked billions of light-years into the past using powerful telescopes. Yet, even with all of our advances, the deeper mysteries of the universe remain elusive. One of the most profound realizations that has come from space exploration is the concept of the pale blue dot, famously captured by the Voyager 1 spacecraft in 1990. From a distance of over 6 billion kilometers, the Earth appeared as a tiny speck in the vastness of space, barely distinguishable from the surrounding stars. This image, and the perspective it represents, has become a powerful symbol of our place in the cosmos, a reminder of both our insignificance and our unique ability to reflect on the universe and our place within it. The idea that Earth is a small, fragile planet in a vast and indifferent universe can be both humbling and inspiring. On the one hand, it forces us to confront the limits of our power and knowledge, and to recognize that we are just one species among countless others in the grand sweep of cosmic history. On the other hand, it challenges us to rise above our limitations, to take responsibility for the stewardship of our planet, and to reach for new horizons in our exploration of the universe. As we continue to explore space, we are also beginning to grapple with the philosophical and existential implications of our discoveries. What does it mean to live in a universe that is so vast, so ancient, and so seemingly indifferent to human concerns? Is there a deeper purpose or meaning to our existence, or are we simply the result of random processes in a universe governed by physical laws? These are questions that have long been the domain of philosophy and religion, but space exploration offers us new ways to engage with them. The discovery of exoplanets, planets orbiting stars beyond our solar system, has expanded our understanding of the potential for life in the universe. We now know that planets are common throughout the galaxy, and that many of them may have conditions suitable for life. The search for life beyond Earth is one of the most exciting frontiers of modern science, and it raises profound questions about our uniqueness and our place in the universe. If we discover life on other planets, it would suggest that life is not a rare or unique phenomenon, but a common outcome of the processes that govern the formation of planets and stars. The possibility of intelligent extraterrestrial civilizations raises even deeper questions. If we are not alone in the universe, how would we interact with other intelligent species? What would this mean for our understanding of ourselves, our history, and our future? The search for extraterrestrial intelligence, SETI, has so far yielded no definitive results, but the search continues, driven by the possibility that we may one day make contact with a civilization that is older, more advanced, and more knowledgeable than our own. Even if we never discover extraterrestrial life, the exploration of space forces us to confront the fundamental mystery of life itself. How did life arise on Earth, and why has it evolved to produce beings capable of self-awareness, creativity, and reflection? What is the nature of consciousness, and what role does it play in the universe? These are questions that lie at the intersection of science, philosophy, and spirituality, and space exploration provides us with new tools and new perspectives with which to explore them. The fragility of life, protecting our planet. One of the most important lessons we have learned from space exploration is the fragility of life and the importance of protecting our planet. Earth is a small, delicate world, surrounded by the harsh vacuum of space. Its atmosphere, oceans, and ecosystems are finely tuned to support life, but they are also vulnerable to the impacts of human activity, from climate change to deforestation to pollution. The view of Earth from space has given us a new appreciation for the interconnectedness of all life on the planet. From space, we can see the patterns of weather systems, the flow of oceans and rivers, and the vast expanses of forests and deserts. We can also see the effects of human activity, the clearing of forests, the growth of cities, and the spread of pollution. This perspective reminds us that we are part of a global ecosystem, and that our actions have consequences for the entire planet. The overview effect, the cognitive shift experienced by astronauts when they see Earth from space, has been described as a profound realization of the planet's beauty and fragility. Many astronauts report feeling a deep sense of responsibility to protect the Earth and to work toward the betterment of all humanity. This experience has inspired movements to promote environmental sustainability, global cooperation, and the preservation of the natural world. As we continue to explore space, we must also take responsibility for the protection of Earth's environment. The technologies we develop for space exploration, such as closed-loop life support systems, renewable energy sources, and waste recycling, can also be applied to solving the environmental challenges we face on Earth. By learning how to live sustainably in space, we can develop new strategies for living more sustainably on our home planet. The fragility of life on Earth also underscores the importance of space exploration as a means of ensuring the long-term survival of humanity. While we must do everything we can to protect and preserve our planet, we must also recognize that Earth will not last forever. Natural disasters, asteroid impacts, and the eventual death of the Sun all pose existential threats to life on Earth. By expanding our presence into space, we can create backup options for humanity, ensuring that life continues even in the face of catastrophic events. Space as the next stage of human evolution. The exploration of space is more than just a technological or scientific endeavor, it is a natural extension of humanity's desire to explore, adapt, and evolve. Throughout history, humans have migrated across continents, sailed across oceans, and built civilizations in new and challenging environments. Space represents the next frontier in this long tradition of exploration and adaptation. As we venture into space, we will face new challenges and opportunities that will shape the future of human evolution. The low gravity of space, the isolation of long-duration missions, and the need to live in closed environments will require us to develop new physical, psychological, and social adaptations. Space colonies on the Moon, Mars, and other planets will present unique challenges, from the need to grow food in artificial environments to the development of new social structures that are suited to life in space. Over time, humans living in space may begin to evolve in response to these new conditions. The human body, which has evolved over millions of years to thrive in the gravity and atmosphere of Earth, may need to adapt to the lower gravity of Mars or the microgravity of space habitats. These adaptations could include changes in muscle and bone density, metabolic processes, and even reproductive systems. In the long term, humans living in space may become physically distinct from their Earth-bound counterparts, representing a new stage in the evolution of our species. The psychological and social challenges of living in space will also shape the future of human culture and society. Space colonies will require new forms of governance, cooperation, and conflict resolution, as well as new ways of thinking about community, identity, and belonging. The experience of living in space, with its isolation, confinement, and dependence on technology, will challenge traditional notions of individualism and self-reliance, and may lead to the development of more collaborative and interdependent social structures. Space exploration also has the potential to transform human culture in more subtle ways. The experience of seeing the Earth from space, the discovery of new worlds, and the possibility of encountering extraterrestrial life all have the potential to inspire new forms of art, music, literature, and philosophy. The cultural impact of space exploration is already being felt in the growing popularity of science fiction, space-themed art, and the exploration of cosmic themes in philosophy and religion. As we continue to explore space, we will likely see the emergence of new cultural expressions that reflect humanity's expanding horizons and our deepening connection to the cosmos. The cosmic future, humanity among the stars. As we look to the future, the possibilities for humanity in space are boundless. The technologies we are developing today, from reusable rockets to life support systems to advanced propulsion, are laying the foundation for a future in which humans live and work on multiple planets, explore the outer reaches of the solar system, and perhaps even travel to the stars. The vision of a multiplanetary civilization is no longer the stuff of science fiction, it is a goal that is being actively pursued by governments, private companies, and scientists around the world. The establishment of colonies on the Moon and Mars, the development of space habitats, and the exploration of the outer planets are all within reach in the coming decades. These endeavors will require immense investment, collaboration, and innovation, but they also offer immense rewards, both in terms of scientific discovery and the long-term survival of humanity. Beyond the solar system, the discovery of exoplanets and the development of new propulsion technologies hold the promise of interstellar exploration. While the distances between stars are vast, advances in physics, propulsion, and robotics may one day make it possible for humans to travel to nearby star systems and explore planets that may harbor life. The search for habitable exoplanets is one of the most exciting frontiers of modern astronomy, and the discovery of a second Earth could revolutionize our understanding of the universe and our place within it. The future of humanity in space is filled with challenges, but it is also filled with hope. Space offers us the opportunity to expand our horizons, to explore new worlds, and to create new futures for ourselves and for future generations. It invites us to think beyond the limitations of our planet and to embrace the possibilities of the cosmos. In the end, the exploration of space is not just about reaching new destinations, it is about understanding who we are and what we are capable of as a species. It is about asking the deepest questions of existence, about life, consciousness, and the universe, and seeking answers that will shape the future of humanity for millennia to come. Conclusion: the next chapter of humanity's journey. The exploration of space represents the dawn of a new era for humanity, one in which we begin to transcend the limitations of Earth and expand our presence into the cosmos. As we continue to venture beyond our planet, we are not only uncovering the mysteries of the universe, but also deepening our understanding of ourselves, our origins, and our potential future. Space exploration challenges us to think on a cosmic scale. It forces us to confront the vastness of the universe and the brevity of human life, while also inspiring us to reach for new heights of discovery and innovation. It offers us a perspective that transcends the divisions and conflicts of Earth, reminding us that we are all part of a single species on a fragile planet, adrift in the vastness of space. As we look to the future, the possibilities are boundless. From the colonization of Mars to the discovery of life beyond Earth, from the development of sustainable space habitats to the eventual exploration of distant star systems, humanity's journey into space is just beginning. Each step we take brings us closer to a future in which we are a multiplanetary species, living and thriving in harmony with the universe. But this journey will not be without its challenges. As we explore new worlds, we must also take care to protect the environments we encounter and to ensure that the benefits of space exploration are shared by all of humanity. We must approach space with a sense of responsibility, stewardship, and ethical consideration, recognizing that our actions in space will shape the future not only of our species, but of life itself. The stars have always called to us, beckoning us to explore, to dream, and to seek out new frontiers. Now, for the first time in history, we have the technology and the knowledge to answer that call. The journey ahead will be long and filled with unknowns, but it is a journey worth taking, not just for the sake of exploration, but for the future of humanity. In the end, the exploration of space is about more than scientific discovery or technological achievement. It is about understanding our place in the universe and fulfilling the human desire to explore the unknown. It is about creating new opportunities for life, knowledge, and civilization in the vast expanse of space. And it is about ensuring that the journey continues, for generations to come. The universe is vast, mysterious, and full of possibilities. As we take our first steps into the cosmos, we do so with a sense of wonder, responsibility, and hope, knowing that the next chapter of humanity's journey is just beginning.